Welcome everyone in this course about 3D in Nuke and how to animate a matte painting. In this first chapter, you will discover the essential points for using 3D in Nuke, such as the 3D viewer, how to create and modify geometries, and how to work with light, shaders, and camera. Now guys, welcome in Nuke. So, as always, to start a project, I'd like to adjust the project settings. So we'll come to the Edit menu up there, Project Settings, and here the two things I'd like to adjust for now is the frame range and the full size format. So my shot will start at the frame 1001 and end at the frame 1100. And I will click on Lock Range to make sure that this frame range won't change when I will import images or other stuff later in Nuke. Now, the full size format. So I will animate that matte painting here. And that matte painting has for format 1920 by 842, which is a kind of weird fake anamorphic format. So this format doesn't live here in the current format in Nuke. So I will simply come here to New and create a new one. And I will name it Anamorphic HD. And then here I can type the size format I'd like. So we'll type 1920 by 842. And I will hit OK. As you can see, my viewer now is taking that new format we created, and this format will be used as well in reformat node and crop node and transform and rotos and everything we will create after. So this is important to start your project by creating the format you are going to work with. Now we can close the project settings and we are ready to comp. So let's move on to the next video to discover the 3D viewer. Okay, so in this course, I'm going to go quite often to the 3D menu here, and it's because all the 3D nodes are here. And I will start right away by creating a cube inside the geometry. Cube, there we go. And we just created our first 3D nodes. So I can recognize that it's a 3D node because it got those soft corners around. For example, if I create a transform node, which is a 2D node, you can see that it's a square box. So this is how you will differentiate 3D nodes and 2D nodes. Okay, I will delete the transform node for now. And for now, nothing changed. But if I connect my viewer to the cube here, you can see that my viewer is jumping to a 3D viewer. Okay, if you don't see the 3D viewer on your end, you can come here to that drop-down menu and switch from 2D to 3D. This menu allows us as well to change to different view, for example, from the side view, from the top view, etc. So for now, I will just come back to the perspective view, which is the 3D view. And now I would like to show you how you can navigate into that 3D space. So you will have to hold down the Alt key of your keyboard, and with your left mouse button you can pan around. With the right mouse button you can rotate around, and with the wheel of your mouse you can zoom and unzoom. Okay? If you don't like those commands, you can come to your Nuke properties. So if you're on the PC, it will be into edits and approximately around here. On Mac, it's under the Nuke here preferences, and we'll come to the viewer handle menu here. And here you have the 3D control type, and you can choose from other control type from another software you will be maybe more confident with. For example, my favorite one is Maya. So we'll simply click on Maya, hit OK, and now I can navigate in my 3D viewer the same way I will do it in Maya, which is more convenient for me, but it's a personal preferences. Now, as you can see, my cube is visible. And if I disconnect my viewer, my cube is still visible in my viewer. And why? Well, to have an element visible in the 3D space, you need to have the properties open here. If I close the properties, the cube disappears. If I double click on the cube and to open the properties, the cube come back. Of course, if your viewer is hooked up to a 3D element and I close the properties, that 3D element will be still visible here as well. If I were to add another geometry, for example, I could create a cylinder. And as you can see, the cylinder, the cube are here. I can see my cube because it hooked to the viewer, and I can see my cylinder because the cylinder is open in the properties. If I was connecting that guy here, I wouldn't see the cube because the cube is not open in the properties and not connected to the viewer neither. All right, I know it's a bit confusing, but trust me, you'll get used to it. Now, if I want to modify a geometry, well, I can easily do it using that little gizmo here. So I need to select the geometry I want to modify first. So here, for example, I click anywhere, nothing is selected, even if it's displayed here and open on my properties bin. I need to come and click on the geometry to be able to display that little gizmo here. And I will be able, for example, to move that guy on X, on Y, and on Z. You could modify those things as well directly into the properties bin here. If you want to scale or rotate your object, you can do it as well in the viewer. You will have to maintain the control key or command on the Mac to display the rotation gizmo. And if you want to display the scale gizmo, you will have to hold down Control and Shift or Command and Shift on Mac. And now you will be able to have your different scale gizmo as well. You can scale everything at once here. As you can see, as I do that, it modifies as well my scale properties here. I do have as well a uniform scale that we use quite often as well, and that we'll see a little bit later. Now, if I want to do the same thing to my cube, I can. Okay, I can move it, hold down Control, and I can rotate it. Oh, pardon. Up. There we go. And Control and Shift to scale. The cube is a bit different because it got that special things where you can select only the corners and modify it like that. But this is the only 3D nodes that allow you to do that in Nuke. Okay, great. Let's now move on to the next video where we are going to see how to see those 3D objects in the 2D viewer. See you there. In this video, let's see how to transform those 3D objects to a 2D image. Okay, right now I'm in the 3D viewer, but if I'm switching back to the 2D viewer, there is a nothing. And this is because we need to render those 3D objects in 2D to be able to use them and see them in the 2D viewer. And for that, I will come to the 3D menu and I will select here the scanline render. And as you can see, if you remember what I told you earlier, it's not a 3D node, even if it was living in the 3D menu. Why? Well, because it's a square box and it doesn't have the soft corner. But this node will allow us to transform a 3D scene into a 2D render. So how it works? Well, I will connect my object to the scanline and let's see if something happened. Well, actually, no, nothing happened yet. And this is because we need to hook up a camera. Okay, so let's create a camera. So the camera is as well living in the 3D menu. And I will select the camera. And I will connect my camera to the scanline render. And things are a little bit weird right now because I don't know what my camera is looking at. So I will switch back to the 3D viewer here and I will come to adjust my camera a little bit. So as you can see, my camera is in the middle of the cube right now. So this is not nice. So we'll just Okay, little mistake. I want to select the Z of the camera here to just move it back in order to have my object in the frustum, the cone here of the camera. So basically it's like in any 3D softwares, and we need a camera here to shoot at the elements we want to render into 2D. Okay, so I can move it maybe a little bit more. Okay, I should have my object now inside my scene. Okay, I will hit the tab key. The tab key is the shortcut to switch between the 2D and the 3D modes. And now I will close all my properties for now. Okay, things open. And now I don't see anything. But if I were hitting the A key to see the alpha channel, I can see that my cube is here. And we don't see anything. The cube is black for now because we don't have any texture for the cube. But it's here in 2D. If I were to, for example, come here and rotate the cube, you can see that my cube is here. Perfect. Now, if I wanted to see in the RGB the cube as well, well, I will just have to apply to it a texture. So for now, let's do something very simple. I will come to the read menu up there and create, I don't know, a color bar, for example. And I will hook up the image input to the color bar. And now I do have a texture to my cube. Now I could do the same thing to the cylinder as well. And I will have to hook up my skyline render to the cylinder, and we don't see anything here, but the cylinder is here, as you can see. It's just that it doesn't have any texture. So well, it's not very well placed on the frame, but it's just here as well. And if I were to hook up the color bar to the cylinder and switch back to the RGBA, as you can see, we can see the cylinder as well. So what if I wanted to see both of those objects at the same time? Well, we could introduce a new node that lives as well in the 3D menu that's called Scene. And the Scene node that we will use as well later will allow us to group several 3D objects, 3D elements together. So I'll connect my cube here and the cylinder as well. And now I can connect the object scene of my skyline render here, and I will have both of my objects. Last thing with the skyline render, we do have here a BG input. And this BG input is for a background. So for example, I could come here and create a checkerboard and connect my BG to the checkerboard. And as you can see, we will have that background here and my CG on the top of it. As well, an important thing to know is that the BG input of the skyline render is defining the output resolution of my render. So for now, if you don't specify anything, it will take the format that we specified in the project settings. However, if you were to connect another thing with a different format, for example, my checkerboard here, I could come here and change it to, I don't know, 8K lat long. Now, the render that will come out of the skyline render will be a 8K lat long. So this is great for changing the output resolution of the skyline render, but the problem is that it adds an alpha to the background. So sometimes what we do if we just want to change the output resolution is to plug a reformat node. And here, the reformat node, we will be able to change the formats that we want to use, and it will change the skyline render output, but it will not fill up the background alpha. Okay, great. This is just a little tip, but don't worry too much about that for now. For now, let's move on to the next clip and see how we could apply lighting to 3D objects. See you there. Alright, in this clip, we are going to learn how to light a 3D scene in Nuke. And I will start here with the fresh Nuke because I'd like to start working on that matte painting that I'd like to animate here. Okay, so we do have here a planet, and this is what we are going to try to do first in Nuke. So we'll come back to Nuke, and I will come to the 3D menu here and create into the geometry menu, create a sphere. And this sphere is going to be our planet. So I will go real quick here because it's stuff that we did in the previous clip, but I will create a scanline render and I will create a camera as well. As a quick reminder, you can create a node by typing the tab key and then searching for the name of the node that you'd like to create. Okay, so I got my camera, my sphere, and I'd like the texture for my planet as well. So we'll create a read node. So coming here to the menu and click on read, and I will navigate to the material folder coming with this course. And under the texture folder, you will find here the planet texture. So we'll open that texture on my read node, and I will connect the texture to my sphere. Now, I need to move a little bit my sphere in order to be seen by my camera. So I will jump off to my 3D viewer by hitting the tab key while my mouse is on the top of my viewer. And I will select the planet here. So just to make sure, when sometimes you don't select the right thing, to make sure you select the right thing, you can come inside your node graph and select the node that you'd like to modify. Okay, now with the Z here, I will just put my planet a little bit further away to make sure that the planet is viewed by the camera. And then I will hit tab again to switch back to the 2D mode. And I will hook up my viewer to my scanline render. And here it is, my planet is here. Great. Now, let's try to apply a lighting to this. So, in order to light our planets, we need to create light. Yeah, no kidding. So, I will come here to the 3D menu, and here I do have a light menu. And I will select the first one, light. So now we have a light, but as you can see, it doesn't affect our sphere. Why? Well, we need this light to be connected somehow to the sphere to be able to affect it. Well, for that, we will use the same node that we used in the previous video, which was here, the scene node. So I will connect my sphere to the scene node, and to the second input of my scene node, I will connect the light. And as soon as I do that, as you can see, the image changed. If I disable the lights, everything is very bright. Well, this is because when we don't have any light in the scene, Nuke will simply display the texture as it is. As soon as you create a light and add it to the 3D scene, then Nuke will take that light in consideration. So now that we create a light, how we will adjust it? Well, first, let's go see in the 3D viewer how it looks like. So we'll go back to the 3D viewer by hitting the tab key. And now in my scene, I have my camera here, we have the sphere here, and here we have the light. And I will move that light for now just to isolate it a little bit. And I don't know if you see here, but as I move the light, I can see that it changed a little bit my lighting on the Earth here, on the planet here. Just to make it more obvious, I will come into the light setting here and increase the intensity. Okay, now you'll see better what I'm talking about. Okay, perfect. Well, now that I see that, I will just have to position my light properly in order to create the lighting I want. Okay, let's set up our Nuke to work a little bit more efficiently with lighting, because this is great to see what's going on here, but actually I will need to jump back to the 2D mode to see exactly what happened. So let's say, okay, I want to put my light here. I will hit tab. Okay, maybe not. So we'll come back here and modify. This is not the easiest way to do it. What I like to do is to create another viewer and try to see in real time what happened in 2D and 3D at the same time. How to do that? Well, you'll see it's very simple. Let's come here, click on the little icon here, and I will click on Split Horizontal. So basically I'm creating a new pane where I can put something else. And I will come into my node graph and do Command I or Control I to create a new viewer. And I will hook up that viewer after my skyline render, and I will move that viewer here, right here. Then we have two viewers. One, the viewer 1 here, as you can see the name, and the viewer 2. The viewer 2 will stay in 2D, and the viewer 1 will be our 3D viewer. So now if I move my light, I can see more or less in real time what I'm doing. Okay, now we are actually ready to light the planet. So let's meet up in the next clip to do so. See you there. Alright, in this video, I'm going to try to recreate the lighting of this planet using the lights in Nuke. Okay, so here I do have a strong lighting coming from the sun behind the planet that creates that rim light on the edge of the planet. But as well as you can see here, we can still see the details on the planet. So what I'm going to do is to create a few lights to recreate that rim light effect, but as well another light to maintain the details inside the planet. So let's try to do that. So first, I'd like to move that light to create that kind of rim light on the side here. So let's move it. So I'm not going to try to be like very accurate as I will do in a 3D software. Here I'm just trying to cheat the feeling of the lighting here. So for example, here that will be not too bad. But the problem that I will have with that current point light is that the fade off doesn't work that great. In order to get like a great lighting with a great fade off, I will have to use the spotlight. So as I switch to the spotlight, I don't see anything anymore. And this is because when it's on spotlight, the light is emitted through that cone here. And I will have to rotate my light for that cone to hit the planet. So how I do that? Well, as we see earlier how to modify things, I will just hold down the Control key or Command if you're on a Mac, and I will rotate my Y-axis here in order to hit the planet. And now maybe I will need to move my lights because we don't see much anymore. Okay, this could be a little bit tricky, guys. So it's normal if you get frustrated at first because it's not super easy to adjust lights on Nuke. So there is another cool tips you could use if you want to adjust a spotlight, is that you can come here and select your light in the list. For example, light 1 here. And now you are going to see what your light is pointing at. And if you do a control click on the little camera icon here, or command click if you're on a Mac, it will turn that camera green, and as you move inside the viewer, you are actually moving your light the same way. So that could be a good way to adjust your lighting a little bit as well. When you are done with that, don't forget to click again on that icon. Otherwise, if you move your mouse around the viewer, you will change the position of your light, and you definitely don't want that. Okay, now that I get that lighting on the side here, how do I get more of that fall off feeling here? Well, I will come to the light parameters, and here I want to adjust the cone angle. And as I adjust the cone angle, oh, what's going on? Okay, maybe, okay, first you need to switch to the fall off, to switch on the fall off, and then you will be able to adjust the cone angle parameter. There you go. Okay, you can try as well to play with the other parameters to see if it's better on your end. Okay, and now I got more of a fade off, a nice fade off. I could adjust the intensity a little bit to get what I want, okay? And maybe move my light as well. But for now, I just want to have more or less just the edge of the planet. Okay, so this is going to be our key light. I'm not going to go through all the parameters of the light. I will let you experiment with it, and it's pretty easy to understand what does what. But for now, let's just rename our light key light. Key light. All right. Now let's create other lights. So I will hit the tab key and create another light like that I will hook up to my scene. And boom, everything becomes flat again. Why? Because we now have a strong point light coming from the camera. Well, good. Maybe I will put it a bit closer here. And I could use that as my fill light, but I will simply decrease the intensity a lot because what I want is simply to keep a little bit of details, but I don't really want to see anything. Okay, cool. And now, so we'll call that fill light. And now I'd like to accentuate my rim light. And for that, I will create a third light. So we'll hit tab again and look for the light, connect it to my scene. And this light, I will change the light type for directional. Now, the directional light is a little bit different as the position of the light doesn't matter. The only thing that matters with the directional light is the orientation of the light. So what I'm going to do here is to increase the intensity of that light to be able to see properly what I'm doing. And what I'm going to do here is to hold down the Control key to access the rotation gizmo, and I will move that light around to try to find the right position for my light. So it's not in this direction. Oops. I just want to affect the green rotation here. Okay. If it's too hard to do it on the gizmo, sometimes it's better to come here and do it manually inside the properties bin directly. So what I'm doing, I'm putting the cursor of my mouse just in front of the decimal here. And with the up and down arrows, I can easily switch the rotation of my light. Okay, so what I'm going to do is just to find like that. Just to try to create a great feeling of real light. Just that hit here. And I think this is great. Can I toggle off, on and off? And I can see that I created a great rim light. Okay, I'm pretty happy with that. Maybe I can boost a little bit the intensity, but we'll be able to adjust that a little bit later. Okay, so here we did what we called a 3-point light system with a rim light, a key light, and a fill light. And you will find that type of lighting quite often. So I just wanted here as well to demonstrate the 3 kinds of lights you can use in Nuke. Don't expect Nuke to achieve crazy lighting, but for simple things that could be very helpful. So now you got the basics, and I will encourage you to play around with those lights to see what you can do. And when you're ready, let's meet up in the next clip to see how we could apply texture and shaders to objects. See you there. In this video, we are going to have a look to the Font shader in Nuke. So if we go to the 3D menu here, we can see that we have a shader category. And if I go there, I can see that there is a few options here. I'm not going to go through all of them, and we will have a look only to the Font shader here. The Font shader will be, I will say, the more advanced shader that you will find in Nuke. So don't expect anything crazy like you will find in a CG software. Actually, it's very basic, but it's kind of useful because you can tweak how the light is affecting your object. Basically, it's a sort of super simple material. So I will connect my Phong shader to my sphere. And as you can see now, we do have that kind of feeling of a plastic texture. Now, this is how that shader is reacting to the lighting we created. For example, if I disable one light, you can see how it changed, right? Now, I will be able to tweak that shader to achieve the look of the texture I'd like. For example, I can here reduce the specular to 0 actually. So all of those parameters here can take a map, and this is why it's pretty great. You can here plug the color, here the map D for the diffuse, the map E for the emissive, the map S for the specular, and if you'd like to tweak the shininess, it's right here, map SH. Okay, so my color, the color of the planet here should be plugged to the diffuse. So I will plug that guy here and I will get more or less the same result with or without. So this is what I was expecting here. So this is great. Now, if I wanted to add some specular, I could. If I will change the color, I could as well. This is great. But what I can do as well is to actually combine map within our shader. And I will try to do that right now by adding some emissive. And for that, I will create a read node and I will go to the material folder coming with this course. And under the texture folder, I will come and select the planet lights. I will open that guy. And now I will connect the new read node to the map E for emissive. And I will come to my Phong shader here and I will increase the emissive. And as I do that, we can see the city lights popping up on our planet. And this is great. Okay, now if you want to tweak it more to add other maps, I let you try around. For me, this is more or less what I'd like. The only thing is that I believe that most of the lights are on the other side of the planet, so I just like to rotate my planet a little bit. So I will come to my sphere and I will rotate the Y, so maybe let's try 50. 50 is great, maybe a little bit more, 70, well, more or less, 60 is nice for now. All right, this is it. So this is very basic, but that could be useful in certain case. All right. Now, in the next video, we are going to see a little bit how to work with the camera node. See you there. In this video, we are going to have a closer look at the camera node and how to work with it. So right now you can see that here I have my camera in my scene and this is what we see here through my camera. And so I could adjust its position here directly in the 3D viewer in order to try to find the framing that I like. But this is one way of working, and this is a way that I like a lot, having a 3D viewer here and a 2D viewer here, and that allows me to do a framing easily. But there is another way which is great as well, and I'd like to show you. I could come here in my 3D viewer to that drop-down menu and select my camera, here camera 1. Now I will look through my camera. So this is great. I could, for example, come here and adjust my properties, and I could do my framing in the 3D viewer directly. Now I could click as well on that option here, and now that will lock my viewer through that camera. For example, I cannot pan anymore. I will be always having that little square here just to show me that I'm looking through the camera. Okay. Another thing I can do, and I think this is one of the best options in Nuke, is to do a control click on that camera here. And now when I'm moving into my viewer, I'm actually moving the position of my camera. Pay attention to those things here. as I'm moving my camera. So this is a great way as well to frame your shots. So just one thing, when you found the perfect framing for you, don't forget to uncheck that camera options, because otherwise, as you will move inside your viewer, you will actually change the position of your camera. Now, as we are talking about how to set up your camera, I'd like to show you that tab here, the projection tab. The projection tab allows you to change, for example, the focal length of the camera. For example, if you'd like to recreate a camera with a 35mm, you can enter here the focal length of your camera. You have other options, the aperture, the near clip, far clip. I won't go through all of this right now. Now, last thing I'd like to show you as well is how to import a camera file. Well, you need to create a camera node, as we have right now, and you need to go to the File tab. And you will click on Read from File, and those options become available. So I will click on that guy here, and now let's navigate to the material folder coming with this course. Inside the 3D folder, I will select the shotcam.fbx, and I will click on Open. Nuke will ask me if I'm sure that I want to read that file, because it will destroy the current camera data. So whatever you modified in your camera will be destroyed by those new data from that file. So here I'm sure, so I will click on Yes. And now I can see if I come back to my camera that those guys turn blue. And this is because we have an animation in that camera file. So great. As well, everything is great, and I cannot adjust those values anymore, just because that node is now in read from file mode. If I'd like to modify the animation or the different attributes of my camera, I just have to uncheck the read from file, and I will keep the data from the file, but now I can go and modify them. In my case, I just don't want to modify them, so I will click again on the read from file. It asks me if I'm sure, because it will destroy the data again, so yeah. And now I'm sure I'm safe that I won't change the data, and I will work with the camera I'm supposed to work with. And this is the camera we are going to use in the next chapter to animate our matte painting. So this is great as it is. So before finishing this video, I'd like to rename my camera to Shotcam, because this is my main camera, and we will see in the next chapter that we will create other camera for camera projections. So it's great to rename your main camera something simple to identify. Alright, well, this is it for this video. I will meet you in the next video to suggest you some homework before going further to the next chapter. See you there. Alright, it was a dense chapter. We've seen a lot. Basically, we've seen how to create primitives in Nuke and how to apply a shader to them and textures, as well as how to light them and render them in 2D through a skyline render using a camera. This is a lot of information, and I would suggest that you play around with 3D before going further. So what I would suggest you to do is to go online, and if you look for free planets texture map, you will actually find a lot. So that could be a pretty interesting and funny things to just try to download a few texture map and to create a few planets and see them in the same viewer. Then you could tweak a little bit the texture, try to play a little bit with the shaders and the lighting and camera animation. Well, this is my suggestion. And when you're done with that, let's meet in the chapter 2 to see how to animate that matte painting coming from that PSD file. See you there. Welcome in chapter 2, matte painting projection. In this chapter, we will learn how to import a PSD file, break it down, and project the different elements on card on the 3D space to add a camera animation. Now, in this video, we will see how to import and break down a PSD file. Now, if you'd like to follow along, but you haven't completed the previous videos, you can open the file v8.nk in the Nuke folder inside the material directory coming with this course. Alright, now let's go ahead and create a read node with the R key, and I will navigate to the material folder coming with this course. Inside the DMP folder, DMP for digital matte painting, I will open the dmp_course2.psd, which is the Photoshop file that we are going to use for the matte painting. So there we go. So we got a normal read node and I can hook up my viewer to it. And a good thing first is to make sure it looks the same as we have in the PSD file. So I will just look at it and switch to Photoshop, and yeah, it's the same thing. All right, great. So now we can see on the read node that we have the usual red, green, and blue channels. But we do have as well the little green square that tells me that there is extra layers in this read node. So let's have a look here if we do have extra layers. And yeah, we just don't have the RGBA, but we have asteroid BG, FG, MG, and so on. And this is great. So what are those names corresponding to? Well, if we go back to the PSD file, we will find those names here, because this is the name of all the layers. Alright, so this is great because it means that I will be able to access to those layers independently. And as we did in the previous course, Your First Shot in Nuke, I will be able to shuffle out those layers using the shuffle node. So for example, if I plug a shuffle node to my read node and I hook up my viewer to it, if I were to shuffle out just the planet, I could get only the planet here. Okay, but here we have something very convenient as well. When reading a PSD file, Nuke detects it's a PSD file and offer you that options, breakout layer. So let's see how it works. Let's click on that guy. Boom. So when you click on that button, Nuke detects all the layers in that PSD file and will break them down and reassemble them according to the PSD file. And so basically you will have all your shuffle node that shuffle your different layer, planet, asteroids, and so on. And here you will have not a regular merge node, as you know, but a PSD merge node. And what is the difference? Well, the PSD merge node will intend to recreate the same fusion mode as you use in Photoshop. Because if you look at the names here, they are different than the one that you have in a merge node here. Some of them may be similar, but sometimes, even if the name is similar, the mathematics behind the operation may be different. So here in that list, you will have the same fusion modes that you have in Photoshop here. Now, important things to do, as we did in the previous course, Your First Shot in Nuke, when doing a breakdown, it's important to compare the input and the output of the breakdown and to make sure it's the same. So I will plug my viewer to my read node here, and I will plug the input 2 of my viewer at the end of my breakdown, and I will zoom in a little bit, and now I will toggle between 1 and 2, and that will allow me to compare my inputs. And everything looks alike, so this is great. Alright, how am I going to work with this breakdown now? Well, I could do some space here and insert all my transform and color operation here before the merge nodes. This is a way of working with the PSD breakdown. If you just want to do, for example, a small adjustment, for example, let's say I want to increase a little bit the size of the planet. I will come here and up. There you go. Now the planet is a little bit bigger. So this is very handy to work that way if you just have small modifications to do. Otherwise, if it's for like a more advanced matte painting animation, I will recommend you to select the layers you need and recreate your own compositing tree. So I will delete that guy here for now. The first thing I'd like to do here is basically first to remove the layers I don't need. So for example, the shot zone, if I come here and disable that thing, is that black mask that just isolates the part of the shot that we are going to see. So I can remove that layer for now, I don't need it. So I will select all that node and disable them with the D key. And I don't need as well those two guys, which are the title informations. Here we have the vignettes, and I will disable it as well because I don't need it for now because I will recreate it myself. And this is it. I will need all the other layers. Okay, I will make a pause here and let's move on to the next video where we are going to reorganize our layers and remake our own tree to get prepared for the animation. See you there. Alright, so now I'm going to organize my layers in order to start my comb tree. So the first thing first is here on the top, I will have the sky. So the sky is this layer and the sun as well. Let's add the sun to the sky here. So I will kind of isolate a little bit those two layers. Then I will have the planet, and I could choose to use the planet from the matte painting, but I'd like to use the planet that I created in CG because it's already in CG and it's already animated, so it's gonna be easier, and we did it, right? So better to use it. But I just want to keep that planet here a little bit just to make sure that I will line up my CG planet here on the top of the one of the matte painting. So for doing that, let's create a merge node, and I will merge the A input of my merge node will go to the skyline render of my planet here, and the B input will go on the top of the other planet here. That way we will be able to compare position and adjust it. So I'll hook up my viewer to it. And there is another thing we need to pay attention here. Right here, we are using the file formats that we specified at the beginning of the course, which is 1920 by 842, which is our anamorphic HD format. And here we are using a file which is slightly bigger of 2569 by 1417. But our matte painting has been thought with the same size formats that we are using in Nuke. Whatever is behind those black bars here are extra pixels for us to use if needed when we are going to animate the matte painting. So basically how it has been thought? Well, this part of the matte painting is centered on the frame. So what I could do here is to use a reformat node, and that reformat node will directly reformat whatever comes from that matte painting to the right format. But as you can see here, it just scaled down everything as well. So what I like to do is not to resize the image, but only isolate the center of the image. And how can I do that? Well, I can go to here in my reformat properties and says resize type center yes, but I don't want to resize anything. I just want this to be none. And as you can see, now it's selected the center of my frame. So maybe the matte painter did a little mistake, and you can see that we have a little gap here, and here is it fine, so I will just boost up. Okay, so maybe we have a little problem of placement here. So what I can do is to create a transform node here. And I will go slowly and try to adjust this to line up perfectly. Okay, and I will do the same with the Y to line up the matte painting. So yeah, sometimes there is a little bit of errors, so just don't be afraid to readjust things a little bit. Okay, we still need to push the pixels a little bit here. Okay, Good. Up there, it's great. And up there, down there, it's good as well. Okay, cool. So we'll revert my gain here. And okay, so this is basically the transform I will need to apply to any of my layers here in order to get the proper format. Another thing I want to do with my reformat here is to preserve the bounding box, because if the matte painter gives us those extra pixels, it's because we may need them. So we don't want to reformat it and kill those extra pixels. We want to keep them in case we need them. And you just want as well to check your transform node to make sure that when you are transferring things, you are not creating any trouble. So you want to uncheck the black outside to make sure that after your reformat, you will keep your overscan. If you want to see your overscan while on the viewer, you can do a right click and select here show overscan. So it won't show everything. As you can see, the bounding box is going until there. But Nuke will stop to the settings you've been setting in your viewer settings. So like for example, if you'd like to show more, you can come on the viewer and hit the S key to access the viewer setting, and here you will have overscan here. And if you want to see more, well, you can increase that value. For example, if I put 400, I will see all the overscan here. While Nuke is set to a little bit less, well, because it costs a lot of memory to display and calculate the overscan. So if you don't need to view more overscan than needed, I will recommend you to leave it to 100. And as well, not showing it if you don't need to see it. Okay, I will close my viewer properties for now, and let's go back here to try to see now if our planet is superposing on the right position. And of course, no. Okay, so I will come here to the sphere and I will come adjust the position. Now, let's make sure that we are on the right frame to work on. And here I'd like to be on the last frame, the frame 1100, because I will use that frame as the reference frame of the position of my painting. Basically, at the last frame of my animation, I want my matte painting to be the way it is coming out of the PSD file. You can choose whatever. Some people will use the middle frame, some people will use the first frame. Here in this case, I want my last frame to be the reference frame. So let's make sure we are on the last frame, and now I will come to my sphere and we will adjust a little bit its position to try to match a little bit better the matte painting. Okay, and now we'll need to move the earth a little bit. Okay, it doesn't have to be perfect, guys, eh? Just do your best. Okay, now, okay, I think it's pretty great. Obviously, it's not exactly the same planet. The lighting is a little bit different, but we will be able to adjust that a little bit later if we want. Okay, good. So now I will add the rest of the matte painting on the top of my image, and I will do that in the next video. See you there. Okay, I can now disable the planet here because I don't need to have the other planets behind this one. Perfect. But now let's add the asteroids on the top of everything. And for that, I will create a merge node and plug my B pipe here and my A pipe to the asteroid background. Okay, let's have a look. Okay, so first let's fix the position. It seems that it's not at the right position, and it's because we need to apply the transform and the reformat as well to reframe properly the document. So we'll just plug that guy here and that guy here. Okay, so now it seems to be in the right position, but it looks a little bit weird. So what's going on? Okay, I don't know if you noticed, but all the layers are actually looking a little bit weird. Why the sun is a square? This is no sense, right? However, when we're merging it, it's not a square anymore. Why the planet is a square as well? And if you were to merge it as well, well, it will be fine. So what is going on here? Well, the thing is that those layers come out unpremultiplied. So what does it mean? Well, it's simple. Basically, we will have a RGB channel, which is the color of our pixels. And we do have as well the alpha channel, which is the transparency of our layer. And when a layer is unpremultiplied, it means that the alpha channel hasn't been applied to the RGB channels. Let me show you a little example here. I do have here a color bar, and this color bar will be my RGB channels, okay? And here with my router node, I just created a simple alpha channel, okay? I will close those guys here, and I will use a copy node to place that alpha channel that I created onto my color bar here. So now I do have my RGB channels here, and if I check my alpha, it's my little circle here. But if I'm looking at the RGBA channels, I don't see any difference. So why? Because we didn't apply the alpha to the RGBA. For that, we need to pre-multiply the alpha to the RGBA. And for that, we are going to use a node that we called premult. All right, I will plug that node after my copy, and boom. Now my alpha is applied to the RGBA channels. Great, well, it's the same thing that we have here. Now if I have a look to this thing, it's just that we didn't apply the alpha to the layer. So I will do it here, and I will create another premult node, and I will apply it right here, and voila, the problem is solved. It will be the same thing as well here with the sun. I could create a premult and plug it right here, and you will see the sun properly. Like if I disable it, square, sun, square, sun. Okay, so why we don't have this problem out of those PSD merge here? Well, because the PSD merge is taking care of the premultiplication for us. So why am I not using a PSD merge node to merge my different layers? Well, because the PSD merge is not as great as the merge node. For example, we don't have multiple inputs, we don't have the mask input neither, and this PSD merge is made to recreate those operations coming out from Photoshop, but it's not really meant to be used in a complex Nuke script. So what I'm going to do here is to recreate the matte painting using normal merge node, but then it means as well that I will have to pre-multiply my layers to be able to use them properly. Okay, let's do it real quick with the second layer of asteroids. So we'll just duplicate all those guys here, Control-C and Control-V. I will plug the B pipe here, and I will connect those guys to the other layers of asteroid MG, and let's have a look. Okay. Good. And I will repeat the operation 2 more times for the 2 other layers of asteroid. I will speed up the video as it could be a little bit boring. Okay, let's have a look. Voila. Okay, we do have a little issue here, but don't pay attention to it for now. We will fix that a little bit later. But otherwise, we fixed that issue of weird alpha by creating a pre-multiply node here. And everything is how it's supposed to be now. Great. So now let's move on to the next clip where we are going to start animating the sky. See you there. Okay, in this video, I will animate the sky. If you'd like to follow along and you didn't complete the previous video, you can open the file v11.nk in the Nuke directory. So now what I want to do is to animate that matte painting. So I could use like transform node and do some fake 2D animation. But well, I got a camera here and I got powerful 3D abilities in Nuke. So I'd like to use them. So first, we haven't looked yet how the animation looked like with that camera that we imported. So let's just have a look here. Okay, we got a pretty basic camera panning around. Perfect. And now if I were to look at it on the top of the sky, how it will look like? Well, it will look weird because the sky will be supposed to move as well as the camera is rotating. Great, okay. So how are we going to do that? Well, I will need to place my sky on the 3D object. And that 3D object then will be shot by my camera. Great, let's do that. So I will create a sphere because it's good to put a sky on a sphere. And that sphere should be very, very big as it represents the sky and the infinity. So let's switch to the 3D mode by hitting the Tab key while the mouse is on the viewer. And I will scale up that sphere like a lot, no, more than that, like 1,000. Okay, we now have a big sphere. We do have a little issue here, and that comes from the far clip of the camera of our viewer. So to fix that, I will hit the S key while my mouse is on the viewer to go to the viewer properties. And under the 3D tab here, I will come to far and I will add a 0 to my far clip. And now it should fix the problem. So close the viewer here, the viewer properties, pardon. And now, well, I will need to apply a texture, the sky texture, to that sphere. So we'll connect, I don't know, let's connect the matte painting to it. I mean, the sky and sun part of the matte painting. And it seems that it's a little bit weird because it stretched my matte painting to occupy the entire surface of the sphere. So this is not what I want. But let's see how it looks in 2D first. So remember to transfer that 3D world into 2D, I will need a scanline render node. And I will need to connect a camera to that scanline render. So we'll use the same camera as here. And so let's organize that a little bit. I will place that camera here and I will make it clean with a little dot here. I don't need those guys anymore, so let's delete them. And I will connect my camera to that guy. Okay, I promise I will make that thing way more clean just in a little bit, but for now, this is good. Okay, let's have a look at the output of my scanline render. So we'll connect my viewer and I will hit tab on the viewer to switch back to 2D. So yeah, this is what I was supposing. It's not working because my texture is applied to the entire sphere. But now it moves. So it's great, right? So we fixed something but we still have another issue. So what I want to do here is I want that my last frame, remember my last frame is my frame of reference. I want that sky to be exactly like that on my last frame. So instead of applying this matte painting as a texture for my sphere, I would like to project that image on the sphere. And that will be like that will texture my sphere by projecting an image, not by applying it to the sphere. So to project that image, I will use a node that we called project 3D. And it's a shader node. So that node can be found here under the shader category and here, project 3D. Okay, so what that node needs, well, it's the image that we want to project, and then we are going to connect that shader to the sphere. And now we need to tell that project node from where we are projecting that texture. Basically, what is projecting the texture. And what is projecting the texture? Well, it's the camera as well. So there we go. I connected my project 3D to my sphere. And now if I look at my skyline render, I got the same thing as I have here. Great. Now let's see when I'm scrolling through my timeline, but it doesn't move. Oh my God, what is going on now? Okay, let's have a look to the 3D viewer. Now, I can see that here, through my camera, I'm projecting that little image here. But when I'm moving through and my camera is moving, the projection is moving as well. Of course, because this is the element responsible of the projection. So if the element responsible of the projection is moving, well, the projection will move as well. And it will shoot the same thing. So yeah, we'll basically showing the matte painting, but if the projection moves with the camera, it won't work. So what we need to do? Well, we need to say that at the reference frame, the camera who is projecting the 3D won't move. And for that, I will use a node that we called frame hold. In the time category up there, frame hold. And I will hook that node here. And I will set the reference frames that we decided. So remember the last frame. So we will say that we want to hold the frame 1100. And now if I scroll through my timeline, you can see that we don't see my camera moving here. Okay, we can see that, okay, we don't see it because of the frame hold. But now if I go to my skyline render outputs and I look in 2D, I can see that now my sky is properly placed on the last frame and it's moving as the camera is moving. Perfect. Okay, we got a last issue that we need to fix here. Why do we have a black band appearing here? Well, it's weird because remember we made sure to keep the overscan here, the bounding box, to keep those pixels information actually to avoid this issue. Well, it's very simple. It's just that we need to go to the Project 3D node and we need to uncheck the crop here to keep the bounding box. And now our sky is animated and we don't have the bounding box issue. Great. Let's now plug that guy here and see with the planet how it looks like. Cool. This is what I want. Perfect. Okay. Well, now let's do that with the asteroids. See you there. Okay, in this video, we are going to create more 3D projections to project the different asteroids layers. If you'd like to follow along but you didn't complete the previous videos, you can open the file v12.nk in the nuke folder. All right, so let's organize just a little bit, right? I will just create another dot here. So remember to create a dot, just hold down the control key or command key on a Mac, and that allows you to create dots like that up, and maybe another one here, and we'll connect that here, and I will have my shot cam here. So why am I just using one shot cam instead of just duplicating that camera everywhere? Because I could do that as well, right? I could do Control C, Control V, and hooked up that guy like that. Well, the reason is that if I want to modify the camera animation, then I will just have only one node to modify, and that's the best way to me how to do it. Okay, so let's duplicate those nodes because this is basically the main nodes that we need for a camera projection. So we'll Control C and I will Control V those guys here close to the first layer of asteroids that I want to project. So the difference here is that I won't project on a sphere, but I will project on a card. So you will find the card node in the 3D menu as well, into geometries, and here the card. So now let's switch to the 3D viewer to see where we are going to position that card. So that card is here, close to our camera, and we want that first layer of asteroids to be very close to our planet. So I will move that card in the Z space here to be just in front of my planet. Now I will scale up that card because I need it to cover the entire layer, and it doesn't matter if the card is actually bigger than what we are projecting, because basically only the element visible will be projected. Everything else will become transparent. So I got the card here. So let's replace the sphere by the card. So to replace a node which is already inserted in the script, you can select your node, start moving it, and do a Command Shift and place the node on top of the other one and release, and the node will swap. Okay, so now I will connect those guys here. I will connect the image I want to project to my project 3D here, and basically whatever is outputted from that scanline render will go to my merge node here. And now I need to connect my camera. So I'll connect my scanline render camera here. I will do it clean with a little dot as well. And like that, for example. No. And now we need to connect as well the camera for the project 3D. So we'll connect it here. But don't forget to place back the frame hold as well, right here. Okay, let's have a look. So, and yeah, everything is moving. This is great. Okay, so I will repeat the same thing one more time for the other layer of asteroids. So I will speed up a little bit the video, as it could be boring to see me duplicating and organizing nodes, but basically I'm taking the same nodes that we just created and I will do the same thing to those two other layers of asteroids. So let's have a look at the animation now. So great, all my asteroids are moving, but the problem is that they are all moving the same way, giving us the impression that they are all on the same distance. And the reason we have several layers of asteroids here, it's because we want to try to create that parallax between those elements to create more distance and more life. So I will need now to come in my 3D viewer and adjust the position of my two other cards that I duplicated here. So let's do that now. So I will pause my player and I will toggle to the 3D mode using the tab key one more time. And now let's see. Okay, so I do have my first card, the card that I created here, and now I have this guy, which is exactly at the same position. So this one is the layer, which is the layer middle ground. So the layer middle ground should be a little bit further here. So let's double click on that card to open the gizmo here, and we will move those ones like in the middle, for example. And I will do the same thing with that card here, and I will move them even more closer to the camera. Now let's have a look and see if there is any difference. Well, apparently there is a difference because things moved already. And let's cache the video and see if we can see parallax between those different rocks. And yeah, it works better. I can see a little shift between the different rocks which are on different layers. Of course, the more layers you will have, the better will be your matte painting animation. And that leads us to another problem. If the objects are too close to the camera, we will need to feel a little bit more of the volume of them. And this is something that we are going to see in the next clip, where we are going to not project on cards, but we are going to project on actual geometries. So see you there. In this video, we are going to project the last layer of asteroids on geometries. If you'd like to follow along but you didn't complete the previous video, you can open the file v13.nk in the Nuke directory. Alright, between those two videos, I went ahead and I just duplicate this setup and I placed a card very close to the camera to project that last layer of rocks. And as you can see here, it doesn't work well. It looks very weird just because the camera movement doesn't cooperate well with the card. We should need to fill more volume on those asteroids. So in certain cases, projecting on card is not an option. So for that case, I will need to project on geometries. And luckily, I asked the 3D modeling department to model me those asteroids in front of the camera to be able to project on them. So in order to import geometry in Nuke, I will need to create a read geo node. So that node will let me import OBJ, FBX, Alembic files. So we'll click on the file button over here and I will navigate to the material folder and we will go to the folder called projection. And here I will take the asteroid fg.obj. I will click on open. And now if I connect the viewer to my OBJ and I hit F on the viewer to frame the elements that I'm currently looking at, I can see that here are my asteroids. Now, when you are projecting on geometries, you need to make sure that you are projecting your image from the same angle it has been prepared in CG. That means that when you have an object to project on, you usually have a camera for projecting onto those objects that comes with the model. So let's create a camera and I will come to the file tab of the camera. If it's not here, it's like right here, okay? Click on read from file and I will come grab inside the same folder, I will come grab the ProjCam asteroid fj.fbx, okay. Okay, perfect. And now I need as well the layer that will superpose exactly to those asteroids. So we'll create a read node with the R key and in the same folder, material projection, I will find the asteroid foreground.xr layer that has been used to place the models behind. So now, if I were to project that layer through that projection camera, this will line up exactly. So let's do that actually. So I'll create a project 3D and I will project from that camera, and that camera is a projection camera, so it shouldn't be moving. So if you have a doubt, you can go to the curve editor and check the curve. If the curves are flat, here it means that the camera doesn't have any animation. Even if we have keyframes, because it's a camera imported, we don't have any animation. So we don't need to actually frame hold that camera inside the Project 3D. Now I will connect the Project 3D to the ReadGeo here, and now I will create a scanline render, and I will hook up that camera for now to see if it's correct. And okay, it's in 3D. Let's see. Okay, it seems that the texture are on the asteroids, great. But now I want to see in 2D. Okay, so this is the output of my scanline render, and this is the input. And the output and input is exactly the same. So it means that the projection works well. Now, in order to shoot those asteroids with the movement, we need to connect it to the camera here. Problem here is the position of those asteroids is totally wrong compared to the rest of our 3D scene. If I were to open, for example, the position of that card that's supposed to be in front of the camera, here, and I will compare to those asteroids, this is wrong. Even if I were like looking at the planet, for example, the planet is actually smaller than the asteroids. So we have a problem here. And to solve that, we are going to move this entire system in space to position and line up the position of that projection camera with the position of our actual camera at the last frame. And let's do that in the next video. See you there. In this video, I am going to line up my projection setup with the rest of my scene, and basically lining up my projection camera with my actual shot cam here. If you'd like to follow along but you didn't follow the previous videos, you can open the file v14.nk in the nukes directory. Now, how am I going to modify the position of my camera and my asteroid at the same time in order to keep the relationship, to keep the projection working? Well, for doing that, I am going to use an axis. What is an axis? Well, we can create one to see in the 3D menu and then axis here. What is an axis? Well, it's that little thing here, which is actually nothing. It's just a 3D point. It doesn't have a geometry to be rendered. This is just coordinates. This axis got translate, rotate, and scale coordinates. And we are going to use that axis to drive at the same time the position of our camera and the position of the rocks here. As you can see here on the camera node, we do have an axis input. And I will plug that axis input to my axis 1 here. And now, if I move this axis, I'm actually moving my camera. It doesn't modify the properties of my camera 1. If you look here, actually everything is great because protected because we are on read from file mode. If you look at it here, I'm modifying the camera. You can see it in the 3D space, but I'm not touching at those properties, which is great. Now, I will need to do the same thing with the regeo and make sure that those guys are moving the same way according to this axis here. So I don't have any axis input on my regeo node, but I can use a node that we called transform geo right here. I will select it, create it, and I will connect that inputs to my regeo and connect that guy here, basically like that. And now there is an axis input here, and I will connect that axis to this axis as well. Now, as you can see, it moved here. Now, if I modify my axis, everything will move together, and the scale as well, and the translate as well. So that way, I'm sure that I'm keeping the relationship between my camera and my object. If I were to plug my scanline render, the camera input to my camera here, and I were to look here in 2D, whatever I will do here, whatever position, scale I will give to this axis wouldn't break my projection. So now, using that axis, I will be able to match the position and scale and orientation of my other camera. So let's do that. I will jump back to the 3D viewer, and now let's see how to match those positions. So first thing first, how this axis is working. Well, when I'm modifying my camera according to this axis, it's a little bit like if my axis were the pivot point of all my objects. So if I want to modify and match the position of this camera to my shot cam, the easiest thing will be first to have my pivot center at the center of my camera. And how I will do that? Well, first, let's revert everything to 0. So rotation as well, scale is fine, and uniform scale should be 1. There we go. Now, let's see the position of my current camera here. So it's very hard to read because it's on read from file mode, so maybe I could just uncheck that guy to be able to see properly what's going on. And if I want my axis to be at the center of my camera, well, I will need the pivot points here of my axis to be at the exact same location. So I could copy and paste those values, but I can as well come here and click on that little menu and drag and drop to my pivot. And that way I could easily copy and paste values. So now, if you look at the axis, it's actually at the center of my camera. And this is better. For example, if I rotate it, you can see that I'm rotating from the pivot point, which is at the center of the camera here. Great. Okay, put it back to 0 for now. And now, well, to match this position, let's see where is actually my original shot cam. So we'll come here, open my shot cam, and go to camera to see the position. So it's very hard to see as well because we are on read from file. So we'll uncheck the read from file. And I can now see what are my positions. So 0, 0, 0, 0, 0, 0. Perfect. It's very easy, right? It's at the center origin of the world. It's as well very important before matching the position of the camera to make sure that you are on the right frame. And here it's 1100 because this is the reference frame for our projection. If I were to use a different frame, maybe my shot cam will have a different position. So I will need to make sure that this camera is now at the center. Well, how can I do that? Well, if my camera has those positions right now, for example, 307 in X and 36 in Y. In order to get the position 0, well, I will need to do a minus 307 in X and a minus 36 in Y. And I will do as well the opposite of the Z position. So let's do that. With my axis, I will take those values and go here to translate. And now it will move the camera a little bit. But if I negate those values by adding a minus here, and plus here, because minus plus minus equal plus, now my camera will be at the center of the world. Now I will do the same thing with the orientation. The orientation is supposed to be 0. Well, let's take the position, the rotation of my camera here, applying it to the axis, and invert it. Perfect. Now the camera is looking at the same direction. And now I need to do the same thing for the scale. And as you can see here, the camera is scaled by 147 points, blah, 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 blah. Okay, so I will select that value. I will select it whole by doing a Control A and then Control C. And as you can see here, it's modified in X, Y, and Z. So basically, it's a uniform transform. So what I can do here is to come to my axis and I will modify the uniform scale instead of modifying X, Y, and Z here. And basically, I need to invert the scale. And so for that, I will do 1 divide, and I can type my formula here by Control V, the value here, and hit Enter. And it will find the actual scale that I need to transform. And so now if I look, I do have my shot cam here. Up. And I have here my camera 1, and they are matching. That's perfect. Okay, so I will connect back my camera here out of my skyline, out of my shot cam, and let's see if my projection is working now that my projection cam is lining up with my shot cam. And if I look at here, and I will switch back to the 2D mode with the tab key, and no. If I check with what we're supposed to see here, well, no, this is not exactly the same. Well, what is going on? Well, we have a problem now with the focal length of the camera. So let's see in the next clip how to solve that issue. See you there. Alright, in the previous clip, we used that axis to align our projection camera here to match the position of the shot cam. But even if we did align those two cameras together, the result of the camera projection here, it's still not looking great. It should look like that, and it looks like that. So what is the problem? Well, if you open the properties of your two cameras, so here I have my shot cam, and here I have my camera 1, which is my projection cam. By the way, let's rename it projection cam. I can see that the focal length is different. We are shooting through a focal length of 50, but we are projecting with a focal length of 35. And as well as the horizontal and vertical apertures are different here and there. If I look in the 3D viewer, I can see that my camera frustum, which is the representation of what my camera is seeing, is way different. Here in green, we do have the projection camera. And here in gray, we have the shot cam. So obviously, we don't see the same thing because even if our cameras are at the same position, they are very different. So I will need to modify those things. The problem is that I cannot modify my projection cam. Because if I modify the focal length of my projection cam, then the texture won't lining up anymore and it will create weird results. Let's revert back to 35. And I cannot as well modify my shot cam because if I modify the shot cam, for example, let's modify that guy here, it will create some weird things here. So no, I cannot. So let's revert that as it was before. Perfect. Okay, so how I'm going to do? Well, I'm going to create a special camera for my projection system. So for that, I will come to my shot cam, select it, do Ctrl+C to copy it, and paste it down there. And I will hook up my scanline render to it. There we go. So I will rename that shot cam for proj, just to identify it properly. And now I will match that camera to the projection settings of my projection cam. Then I will save my shot cam for the rest of the scene and I won't destroy any of my work here, but I will have a special shot cam for that projection. So I can close the shot cam here because I don't need it for now. And now let's modify the shot cam for proj. Okay, first thing I like to modify the focal length. And I can see that it's blue. It means that there are keyframes here. Well, I don't want keyframes, so I could go and delete all the keyframes for all the keyframes that I have, but it seems that there is keyframes on all the frames, so it will be a lot of work. So I could go to my curve editor and delete the key from there or the dope sheet. But what I can do as well is simply go there, do a right click on focal length and click on no animation. And that will simply delete all the keyframes that I will have for that attribute. Don't worry, you will keep the keyframes for the other attributes. You're just deleting that guy here. Now I can change the value for 35. Okay. And now I will copy as well the horizontal aperture here and the vertical aperture here. And now if I look out of my scanline render, this looks like something I could use. So I don't want to lie to you by telling you that this technique is perfect. And if you compare the input and the output, it's actually a little bit different. Well, this is because we are using truncated values here, so the result is not 100% accurate. But here, this is something we can use, and this is great. So I will simply delete those guys here because I don't need them anymore, and I will plug that guy out here. And now if I look at my comp, I can see that I have my rocks moving and I get that very nice parallax between my object. This looks very cool. Great. Okay, before ending this video, I still have a little problem here. As you can see, this rock is cut in the middle. And maybe it's because I didn't went on my Proj 3D here and disable the crop. No, because now I got stretched pixels instead. This comes from the fact that here we actually don't have extra information. We don't have bounding box with extra pixels for that rock. So when we are on the frame that is showing a place where we don't have anything to project on it, well, it will just show stretched pixels, which is not nice. So there is two solutions for that. The first one will be to come here and to paint extra texture for that rock, which is a great solution. But here I like to do it quick. So the second solution is to simply remove that part of the projection. And I will do that now. And I will use for that a rotor node that I will create with the O key. And I will just draw a garbage matte around that asteroid here. And I will now create a merge node with the M key. And I will plug the merge node right after my asteroid for the B pipe. And I will plug the roto to the A pipe. And I will switch my operation of the merge node to stencil. And now if I look from my viewer here, I can see that I removed that rock. The stencil operation is used to remove things from an image. So now if I look out here, I can see that I don't have that rock that bothers me anymore. Here, not here. Perfect. Alright, let's meet up in the next clip to see the shot being cached and to assign you some homeworks as well. See you there. Alright, so I cached the shot, and as you can see, Nuke is a little bit struggling to play it real time. It's a bit heavy for my computer. It's playing right now at 18 frames per second, but well, that's enough for me to see that the animation is working and the parallax between the rocks is pretty great. Now, I will need to make sure that my shot is looking the same way as the matte painting, but I will do that in the next 2 chapters. For now, I'd like to give you a little homework assignment if you'd like. I think it will be interesting if you were to do your own projection on this shot. For example, you could go online and try to find some pictures of space junks, and you could try to add layers of space junks in this shot by projecting them on cards. Or if you know how to model, maybe you could try to output something out of your CG software and project it on geometry, as we did on the previous clips. So I think it's an interesting homework to do. But if you are ready, let's move on to the next chapter where we are going to talk about the depth pass. See you there. In this chapter, you are going to learn what is a depth channel, as well called Z-Pass, and how to use it to grade your comp and to apply depth of field. But first, let's see together what is the Z-pass. Alright, I'm back in Nuke here. And let's have a look to that depth channel. So if we are looking at the scanline render here, we can see that we are outputting red, green, blue alpha channels, but as well a bunch of other layers. So one of them, that purple one, is the depth channel. So let's connect the viewer to the scanline render and come to that drop-down menu here and select depth. And this is a depth pass. A depth pass will map each pixel with a value corresponding to the distance from the camera. Here, in our case, the brighter it will be, the closest from the camera it will be. As you can see, when I move my mouse, that value will give us the distance value. So here is a little representation of how it works. We have distance units that are mapped between 0 and 1. 0 being the further away and 1 being the position of the camera. But this is true for Nuke, that outputs values of depth mapped between 0 and 1. We could have different things. For example, Arnold will output direct distance values. For example, if the ship is at, I don't know, 10,000 meters from us, then the value of the pixel will be 10,000. And we will see a little bit later how to use those values. So those depth informations are super useful because we are going to be able to use them to generate a mask. For example, let's say we could isolate only, the first rock here. So I'm just adjusting the viewer here, but we will do that with a grain node. And for example, those rocks could be more contrasted, and we will be able to use that black and white thing as a mask to drive our color correction. But as well, we will be able to use all those depth information in our scene to be able to apply depth of field. And this is as well super important. So let's move on to the next clip to start seeing how to use those depth information. See you there. Alright, in this video we are going to learn how to merge depth passes. So if you didn't follow along but you'd like to follow this video, you can open the file v16.nk in the Nukes directory. So we've seen that we have depth informations coming out of that scanline render here. But we do have the same thing coming out of every scanline render nodes that we created. For example, here, this is the distance of that layer of asteroids. And here as well. So a little thing that I'd like you to notice is that we will have a difference here between those layers of asteroids and the last one, because those asteroids are actually projected on card. So basically there is no volume information. So all the asteroids here are going to have the same distance information. And here, because it's on geometries, we will have variations between those asteroids, which is true as well with the planet here, because it's a real geometry. So that part of the planet is not at the same distance that the edge right there. So in order to use properly all those depth information, we will need to merge them together. And unfortunately, we cannot merge them with a simple merge node. Well, it's not true. We could, but it's not very accurate and not easy. For merging Z information, we have that node, which is called the Z merge. So I hit tab of my keyboard and I'm looking for the Z merge. I will create a Z merge, and all the Z information are outputted by my scanline renders here. So I will simply start connecting the input of my Z merge to my different scanline renders. So 1, 2 here. And as soon as I connected the two first inputs, I have a third one that pops up here. So I can keep going here. And now I have another one. So that's perfect. Basically, I will be able to connect all my scanline render output to that ZMerge node. Here. And finally here. And now let's connect our viewer to the ZMerge here. And everything is black, which is not normal. Let's see the RGBA. As you can see, we can only see the sky as well. So there is a little problem with the ZMerge. If I were using a normal merge node, I will simply say, well, I just did a mistake with the order of my layers. But the ZMerge doesn't work the same way. The ZMerge will merge the different layers according to the Z depth informations from the distance information. But the thing that we need to change here in the ZMerge properties is that guy here, smaller z further away. And this is because we are using Nuke's depth informations coming out of scanline renders. And as you can see in the help that pops up, it tells us that Nuke use that kind of renders. As we can see here on that slide, Nuke maps the distance between 0 and 1, 0 being the further away, 1 being the closest to the camera. We wouldn't use that smaller z option if we were using, for example, Arnold rendered, which are mapping direct distance values, and the greatest that will be the value of the depth, the further away it will be. Now, when I check that box, everything looks correct. And if I go back here to check at the depth, I can see that the depth looks correct as well. And this is great. As you can see, like, here are the closest rocks with a value of, for example, 0.48, and we have the intermediate rocks with a value of 0.27, we have the planet here with a value of 0.13, and the sky, which is not totally black, as you can see, because we have a value of 0.001. So the ZMerge is working. Well, we have just that little issue to fix here, and that's come from the fact that here we have trouble interpreting the alpha channel of those different layers, so I will just disable it. Depending the type of depth that you are using and the type of render, you will use or not that alpha channel. In our case, outputting out of scanline renders, we actually don't want to use the alpha channels. As you can see here, when I checked on the alpha channel, I create those weird edges that have actually a greater value than inside of the layers, so it's totally wrong. So let's uncheck it. And now everything looks great. Okay, cool. Now, in order to use that depth pass, I will extract it, I will shuffle it out. So after my ZMerge, I will hit tabulation and look for the shuffle node and shuffle the depth pass here to the RGBA. Now I can connect my viewer out of the shuffle node and look at my RGBA channels. And here it is. We do have our depth pass with all our layers, and we are going to use that to grade our comp. So let's move on to the next clip to do that. See you there. In this video, we are going to use the depth informations to color correct our image. If you didn't follow along but you like to follow this video, you can open the file v19.nk in the Nukes directory. Alright, so let's start by creating a color correct node with the C key. And I will plug that color correct node after the last merge of my main comp tree. And now let's have a look to this thing here. Well, we could use that thing as a mask. So I will plug the mask input of my color correct to the output of my shuffle node here. And now, if I connect my viewer out of my color correct here, I could, for example, come here, increase the gain and the saturation, and as you can see, only the parts of the mask which are the brightest are affected by my color correct. As you can see, the sky here won't be affected because it's almost black. But the first objects here are the one which are going to be the most affected by my color correct. And this is the way I want to use my Z-Pass to grade things. Of course, in my case, I don't want to use that Z-Pass to just boost the saturation here, but we are going to be able to do other things. For example, something that we do a lot in compositing is to modify a little bit the perception of the black values according to the distance. Most of the time, if you look at images, the closest the elements are from the camera, the more contrasty they are. And as you go further away, they tend to get a little bit more washed out. So in our case here, it's not very, very true because we are in space, and in space there is no atmosphere, but let's pretend there is, just for the sake of using our Z-Pass here. So I will revert those controls to 0 for now. And what I want to do is to modify a little bit my Z-Pass here to just create the mask I want to modify my image. First of all, here I like to affect the further objects and not the closest one. Let's not touch to the first rocks and just adjust what is the further out from us. So I'd like the sky to be white and those elements to be black. I need to invert my mask basically. Well, I can do that by creating an invert node. So I will hit tabulation and I will type invert. And there we go. As you can see, now the values which were dark are now the bright ones, and the closest object here are darker. So that's great. Now, I'd like to modify a little bit more because I don't want to affect at all those elements. And if those elements are kind of gray, it means that they are going to be affected a little bit. So what can I do? Well, I can create a grade node after my invert, and I will do that with the G key. And now I will change the channels to RGBA to make sure that I'm actually affecting the 4 channels. And now with my black points and white points, I can adjust that thing to just select the part of the distance that I'd like to affect. For example, if I don't want to affect at all those rocks, I can just increase my black point to make sure that I won't affect those rocks. Let's go even a little bit more further. And if I want to make sure that I'm affecting the sky and the earth the same way, I could decrease a little bit my white points to just take them all together, right? Actually, I like to have a little bit of a separation between the sky and the earth, so I will just reduce the white points a teeny bit. There's something as well I want to make sure when I'm tweaking my mask here. It's easy, for example, to increase the gain and not realize that we are actually getting values over 1. For example, if I sample the sky here, I can see that I have a value over 1 of 2. So it's important when creating a mask to come to your grain node and to click on white clamp to make sure that your alpha value will never go over 1. As you can see now, I'm at 1 here. Okay, but I don't want to use the gain here, so I will just revert that knob to 1. But now let's try to use that mask with my color correct. I'm not sure that that mask is perfect, but a good way to do things is to first look at the color correction with the color correction, and then we'll be able to come back here to the grain node and adjust it if we need. So now I just like to adjust a little bit the dark part of the further away elements. So for that I will come to the shadow part here and let's increase a little bit the offset. As you can see here, I'm just affecting the objects which are further away from us. So you can do whatever you want. Usually what I'm doing is always doing a little bit of a crazy adjustments to make sure that I'm affecting the right elements. Then I can come back to my grain node and adjust a little bit my black point and white point accordingly. For example, here, well, here it's fine. So I will close that grain node and now I can adjust more what I want to do. So I will reduce the offset just to a teeny bit, and I'd like as well to introduce a little bit of a blue color in the dark values. So let's put a little bit of blue here. And we always tend to do too much while doing color correction for the first time here. So what I usually do is do my color correction, blink my eyes a little bit, and then come to the range here and to go to the mix attribute of the node and to be able to just remove what I've done, put it full, and try an intermediate values just to see what is right. Okay, for example, I think this is quite right. And then of course you select your node and do the D key to disable and enable, to toggle on and off to see how it looks like. All right, well, I think it's good. Maybe a little less. I will put it at, yeah, point. Yeah, it's a little bit better. It's just a teeny bit, but that could help, especially if you had atmosphere. Here in space, well, I don't know, but yeah, why not? It could be part of the art direction as well. Okay, so basically this is it. You are using your Z merge here to create that layer with all your depth paths, so that will map all the values from the object the further away to the closest one. And then with a bunch of gray node and invert if you'd like, you can create the mask you want to delimitate the objects you'd like to affect with your color correction. So this is pretty strong. All right, this is it for this video. Now in the next video, let's see how to use the same thing to merge matte painting elements. See you there. So I'd like to show you as well that you can really use that mask the way you want. Basically, you don't have to use it for color correction. You could use it, for example, to merge a matte painting layer. For example, if we look at the matte painting layers that we have here, we disabled earlier the vignettes, which were actually important because it was darkening the elements which were behind the first rock. So, well, why not to try to merge those elements back? So we'll enable those layers, and of course I will need to as well apply the premolds, transform and reformat as well to that matte painting layer. So let's connect them, vignette here. And I could merge that thing, for example, after my color correction right here. So I will create a merge node, a normal one. I will connect the B pipe after the color correct one here, and the A pipe to my matte painting layer. And now I will use the alpha that I generated for my color correction and plug it into the mask of my merge nodes to merge that new layer, but to merge that new layer behind the black elements here. So let's have a look. There we go. So let's toggle on and off, on and off. As you can see, I'm actually merging the vignette, but I'm not affecting the first elements here. So this is another very useful way of using the Z-Pass. Oh, as you can see here, we do have a little problem with the position of the vignette, and that may comes from that transform node. So let's open that guy and modify a little bit the X position to line it up properly. Yeah, I think that's great. Oh, maybe not. Okay, a little bit less. Okay, cool here, and hopefully it's great on that side, on the bottom, on the top. Okay, cool. So yeah, this is it. This is a very easy way to use the Z-Depth as well to merge matte painting layer. Now let's move on to the next clip to see how to use the Z-Depth information to create depth of field. And you'll see, this is great. Okay, see you there. Okay, in this video, we are going to apply a depth of field to our shot using the Z-Defocus and the Z-Pass. If you'd like to follow along, you can open the file v21.nk in the Nukes directory. All right, let's look for a node called Z defocus. So I'll go to the blur menu here, and I will select Z defocus. And I will plug the image input to the main COM tree here. And I will plug my viewer after the Z defocus. And for now, everything is blurred. Well, maybe it's what you want, but no, this is not what we want here. We want to blur only things according to the distance. Well, for doing that, we need to specify what is the depth pass in our main tree. For now, we do have a depth pass that we merge here, but this depth pass is not in our main COM tree. So I will need to inject that depth pass in our main COM tree here. And for that, I will use a copy node that I will find in the channel menu here, copy, and I will plug the B pipe of my copy node to my main tree and the A pipe to the Z merge here. So maybe you remember we used that copy node to copy alpha in the previous course. Here we are going to use that copy node to copy the depth pass that we created here in the Z merge. So for that, I will come to the attribute of that copy node, and in the copy channel, I will replace rgba.alpha by depth.z to depth.z. So basically, I'm copying the depth channels here to the main pipe. Now, if I come back to the properties of my Z defocus, I will be able to adjust here the focal point. If you don't see the focal point, it's maybe because your overlay is toggled off, and you can toggle it on and off using the Q key while your mouse is on the viewer. So I will take that little guy here and I will drag and drop it to that rock here, which I know is the closest from the camera. So I will drop it here, and now there we go. We can see that this rock is sharp, and as we go further in distance, things start to be blurry. Perfect, this is exactly what we want. Now let's see how we could use that Z defocus a little bit more. The first thing I'd like to talk about here is the math menu. And this is where you are going to choose what kind of depth pass is using to drive the Z defocus. And in our case, far equal 0 is correct because we are using the new depth pass, which is mapped between 1 and 0, 1 being close to the camera and 0 being the further objects. So far equal 0 is correct. But for example, if we were using an Arnold depth pass, we will use the direct up there. Now, if you have a doubt regarding the math, you can simply hover your mouse on the top of the menu, and that will give you a little bit more of explanation. Sometimes it's a little bit confusing, but don't worry, you'll figure it out. Now, if you'd like to set up precisely your focal point and your depth of field, you could come to that menu here, output, and you could select focal plane setup to be able to define where is your focal plane. Or you could use as well the layer setup to do the same thing. And the difference between those two guys, this one is displaying your image behind, and this one is displaying the Z pass. I really like the Z pass because it gives me the sensation of volume, and that's sometimes a little bit more easy to adjust my depth pass. Now, for example, let's see those rocks are sharp, more or less, because the red color means it's too close from the camera to be sharp, and the blue color means it's too far from the focal plane to be sharp as well. Normally, when it's sharp, it's going to be the green color, and we are going to see that while increasing the depth of field. There we go. Now I'm defining what is exactly sharp. The green will be sharp, the red will be too close to the camera, and the blue will be too far from the camera. So you really can set up your depth of field as you want. Of course, it won't be like sharp, blurred, right? It's there is a transition between those areas like a real camera will do. But so you can really play with that and create the defocus you want. So let's go with that for now. I will just go back to the results here. And now, if I want to increase my depth of field, well, I can come to the size here and put a bigger value. For example, let's go to 20. Let's see what's going on. Wow, okay. So now you can really see that those guys are sharp, but everything else behind is blurred. Now, we put a value of 20 on the size of our blur, but we do have another control here, which is called maximum. And this maximum is a sort of a clipping, a threshold for the size of our blur. For example, if I were to zoom on the background, and if I were to put 15, then the size of the blur will be the same because the maximum here is 10. So if I were increasing that guy to 15, I will change now the size of my blur, of the maximum of my blur. So why do we use that maximum value here? Well, for two reasons. The first one is that the Z defocus is a pretty heavy node to calculate. So it's very important here to have a threshold to use just in case of your computer is about to explode. Sometimes I will use a maximum value while I'm working in Nuke to spare a little bit of computer power, and just before rendering, I will increase my maximum value. The second reason we use that maximum value is to drive the difference of blur between the further elements and the one closest to the focal plane. So for example here, if I were to change the size, I will be able to increase the blur of my midground element without affecting the blur, the maximum blur which is applied to my sky here, for example. So let's do a test by putting a size of 30. Just look at that part of the screen. And there we go. As you can see, now my elements are more blurred here, but the blur on my sky remain the same. And that will be a little bit like adjusting the aperture of your camera. Okay? So this is actually very useful. Those two ways of using that maximum value are pretty important. Okay, now there is another thing I'd like to show you about the Z defocus node. It's about how you could create a filter type to create some bokeh. And we are going to see that in the next video. See you there. In this video, we are going to use the filter type to change the look of our bokehs here. If you'd like to follow along but you didn't complete the previous video, you can open the file v22.nk in the Nukes directory. Okay, as you can see here, I have a lot of bokehs and they are all circular. And I could change that by coming here to the filter type and switch from disk to bladed. And as I do that, boom, my bokeh is changing. And now I have a bunch of controls that I could adjust to obtain the bokeh I like. For example, I could put more blade like 8, or I could change the roundness of it, or many other parameters, as you can see. And I will let you play with it. But if you'd like to see more what you are actually doing to your bokeh shape, you could come to the output menu here and select filter shape setup. And that will give you the bokeh that you are using here. And that could be maybe more useful, more easy to adjust to get exactly what you want. And when you're satisfied, well, you will go back to the result output and you could see your bokeh here. So Nuke as well has the ability of using bokeh images. And you will plug it to filter and you will use it, the image here, but this will be for a more advanced course. For now, I will use that type of bokeh, but I will not keep that level of depth of field for my shots. This was just for the example. I actually want something very, very small. I will put something like 2. I'd rather to have my things sharp. And I will reduce the maximum as well, maybe to 5. So the problem when you are actually animating a matte painting and adding Z defocus to matte painting is that you are losing a lot of sharpness. Well, of course, we are blurring it, but sometimes it's great to create depth of field, but sometimes it really, decrease the quality of the matte painting. So we have to be careful with that. And in the next chapter, we are going to add grain to reintroduce a little bit of sharpness, of definition. So we are going to readjust a little bit the defocus when we added the rest of the effects on the top of our comp. But for now, this is it for the Z defocus, and I will meet you in the next video to assign you some homeworks with the depth pass. See you there. Okay, this is the end of this chapter, and I'd like to assign you a few homeworks, but just before doing that, let's tidy up a little bit my comp, and mainly that Z merge here, which is linked to all the scanline renders of my comp. So I'd like to double click on the scanline render to open the properties and come to the node tab here, and here I will click on hide input. And now if I deselect the node, all the input will be hidden, which is very great to clean a little bit a comp. Now, well, let's move that guy a little bit and maybe create a dot here. Remember to create a dot, you maintain the control key or command key on a Mac. There we go. Now, one thing, just be careful when you use hidden links, because we tend to forget that we link nodes. And for example, I could modify drastically this part of the script and not remember that I'm actually affecting as well something which is linked a little bit down. And then I'm like, okay, I just changed that part of the script, so why everything regarding my Z grading is not working anymore, So I think it's important not to use too much hidden links, because yeah, it helps a lot to clean your script, but that could create confusion down the road. All right. Now for the homeworks. Well, I think it would be great if you were trying to work a little bit more with the Z grading, and mainly to try to create your own mask using the Z pass and the grade nodes. So for example, you could create other grade nodes and try as much as you can to isolate only one type of element. For example, you could create a grade nodes to try to grade only the asteroids. All right. Okay. Maybe this is not right because this is white, this is black. Maybe we should invert it. I will leave you to decide that. And for the second assignment, I'd like you to try to play a little bit more with the Z defocus and try to create a rack focus. So remember, we can animate all the parameters in Nuke. Well, we could animate as well the focal plane. Let's imagine we were intending to create a miniature kind of filling shot with a very shallow depth of field, like if everything was very small. Now, at the beginning of the shot, we could imagine that the focus is on that rock. And we could create a keyframe here on the focus plane. And now we could go to another frame and move the focal plane to the planet here. And as you can see, I created a keyframe to the focal plane here. So now between those two frames, I will have a rack focus interpolation, and that could look super cool. So I will let you experiment with that. And when you are ready, let's meet in the next chapter to learn some cool techniques to give more life to your matte painting. See you there. In this chapter, you'll learn techniques to add more life to your matte painting. We'll start by adding animated volume rays. Then we'll learn how to use 3D data to drive a 2D transform to animate static elements such as the lens flare. We'll add grain, chromatic aberrations, and finally we'll dive into render settings to optimize the quality and motion blur of the 3D elements. Alright, let's start with the volume rays. If you didn't follow along the previous chapters, but you'd like to follow here, you can open the file v24.nk in the Nukes directory. Okay, so I am going to do some volume rays that comes from the sun and that will kind of go through the rocks and kind of give the feeling that it passed through, dropped shadows and a little bit of light. It's a little bit hard to explain with words right now, so I'll show you what I just did when I prepared this course, and this is something looking a little bit like that. So of course our shot will look a little bit different because we are starting from scratch here, and I just don't want to do a copy and paste of that node to recreate the new one, and as well because I'd like you to see my process when I'm trying stuff. This is going to be a little bit different than the previous chapter where everything is falling in place perfectly. Here we are going to do a little bit of trial and fail, so bear with me. But I think this is a great process to learn, to see how we actually try to think the effects and make it work properly. So I will come at the end of my comp and I will hit the tab key and look for volume rays. I will select that node and create it. And now this node is the node that will create the volume rays. If I hook up my viewer to it, for now there is just nothing. We do have this little volume position here that I can move around, but nothing is happening. For this thing to work, we need to plug an image. For example, let's plug the output of our asteroid here. Now that we have a shape, the shape that we are inputting to our volume rays will be used to generate rays. Right now, the mode that we are using is the luminance of the image that we are inputting. So what is going on here? Well, the thing is that we are using the luminance of that layer, so we are emitting from all the bright parts of the rocks. Well, this is not what I'm going to use, but this is just for demonstrating you how it works. Now, the thing that I want to use here is to actually use the alpha of those elements just to generate rays and give the feeling that all those rays are going around. So I will switch that guy from alpha edge. And now you can see that it's a little bit like the edges of my alpha were emitting lights, but it gives as well the feeling that there is a light coming from behind. And this is the effect that I'm going to use here. But I don't want to have only those first layer that cast those rays. I want all the asteroids to be part of the same thing. So what I'm going to do right now is to merge all my asteroids together to create that image alpha that I will use to drive the volume rays. Okay, so the first layer of asteroids are here. So I'll create a merge node and I will merge the B pipe here with the scanline render. So as we did in the previous chapter to merge the depth paths, we were like, well, we don't care about the order. Here, we care about the order. It's important just to recreate the proper layout for this thing to work well. So now I will have on the top the second layer of asteroids. Then I will come here and I will add the third layer of asteroids. And finally, we have the last layer of asteroids here. Now, if I connect my viewer to it, I should have all my asteroids together. And I will use that and use that alpha to drive the volume rays. Okay? Perfect. Okay. So I will connect that guy to the volume rays node here. And let's see how it looks like. Well, for now it looks very weird, but it's a good start. Okay, so now basically those volume rays are supposed to come from the sun. So I will, even if it's not ready, right, I will create a merge node in order to merge my volume rays on the top of my scene. So we'll just merge everything after the Z defocus. And as we did earlier to set up the matte painting, it's important to choose a reference frame. So we will do the same thing here, choose a reference frame, and then we'll take care of the animation a little bit later. So for now, we always use the last frame to mock up everything. So I will keep using the last frame. So I will come to frame 1100 here. And I will now move the volume position to the position of my sun here. And you can experiment. You can just move the thing around till you find a position that you actually like. Okay. I think that this position is not too bad. Alright, so this is the first step of creating this volume rays. We created the image that will cast the rays. Now, let's move on to the next video to see how to tweak that volume rays node. See you there. Alright, in this video, we are going to tweak the volume rays to achieve the look that we want. If you didn't complete the previous video but you'd like to complete this one, you could open the file v25.nk in the Nuke directory. Okay, now let's double click on the volume rays and let's start adjusting them. So the first thing I'd like to do here is to fix that repeating pattern issue that looked like a quality issue to me. So I will come here and look for something that's called quality right here. And I will click here and set to high. And now everything is smooth. Now there is two main things that I can adjust here in the volume rays. Here will be the shape of the rays and here will be the color. For the shape of the rays, I'm not too sure yet. I think this looks pretty great, but you could play around with the length of the rays to see how it will look like a little bit longer. And if you'd like them to be a bit more blurred, I like them sharp. As well, those two guys here will help you to define the alpha that generates your rays. So basically we are taking the alpha of all the rocks here and then we are taking the edges, and this will make your edge more or less thick, so that will influence the size of your rays, right? And that will affect the sharpness of the edge of your alpha, so you will get as well different results depending of what you are using. So I really want you to decide what you want to achieve out of that. I don't have like, you have to set the edge size to 1.8 or 2.6. No, just choose, just play around with all those parameters to see what you like. As well, it's important not to be afraid to play with parameters of nodes in Nuke, because you will encounter new nodes all the time in Nuke. Like every new project, every new companies will have their own plugins, their own gizmos, their own nodes, and they will be different. And you will be like, okay, how am I going to use that? Well, simply by trying things. You'll see. Don't be afraid. Okay, so when you're done tweaking the look of your rays, let's have a look to the color. So first, we could change the gamma and gain of the volume rays, but this is not too much my concern, because those two things could be adjusted outside of the node by using, for example, a color correct node, right? But here, I really like the initial volume color and the end volume color, because that will allow me to create a gradient between the emission and the end of the rays. So I will just come there and tint a little bit the initial volume color with a little bit of more of a warmer tone. And maybe I will actually do the opposite for the end volume color. Come here and put a slightly colder tone. So I don't know if it's exactly the look I want to achieve, but well. Of course, I will then place my color correction after, and just for the sake of it for now, just let's add a little bit of orange feeling to the gamma, and maybe to the gain as well. I don't know. Yeah, just a little bit like that. This is not perfect for now, but we are going to adjust things more, right? As I'm putting elements into place, I just realized that there are other stuff as well that needs to be adjusted, right? I'm still not very convinced about my defocus, and as well the edge of the earth right now could be maybe a bit brighter, because we need to justify the fact that we have all those rays coming from the sun, right? So maybe the edge of the planet, sorry, not the earth, need to be brighter as well. So now, the problem that I have with those rays is that they are emitting everywhere. Well, it depends of your art direction, and you can do whatever you want, but I like to see a little bit more of that part of the screen being just in the shadow with not that many rays, like a little bit like if the planet was occulting some of the rays that couldn't pass by, right? And here in the volume rays here, we have a mask input that we could use for that. So I will take that guy and I will come and connect it to the earth here. Okay, now my problem is that I have links crossing my scripts all over the places. It starts to be a little bit of a mess here. So we'll come to my merge 8 and I will do the same thing as we did with the Z merge, and I will come here and hide the input. And here I'd like to hide the input as well that comes from the planet. But I don't want to hide all the input from the volume rays, because if I do that, I feel it becomes confusing because we don't know what where the things are coming from, you know? Especially with that type of node that has labeled inputs. So we know that here's the image that generates the rays and here is the mask. So if I hide the inputs from this node, things are not very clear anymore. So what I'm usually doing in that case, well, I will just simply create a dot here on the link coming from the planet, and I could double click on the dot and hide the input of the dot. And I think this is way more clean. I could do even better. I could come here and label my dot and call it, for example, planet. We'll increase a little bit the size of the text. And now this is like way more clean. I could even create a dot like that. And yeah, perfect. Okay, so now I plugged my planets as a mask in the volume rays, but basically nothing happened, nothing changed. Well, it's because we need to go back to the main user tab here, and at the end of the properties of the volume rays, we need to enable the mask. And as soon as we do that, you can see that we're actually affecting the effects, and now we have rays only inside our mask. Well, the thing is that we want the opposite here, right? So I will hit the tab button and looking for the invert node, and I will plug the invert after my planet here, and there we go. Now we do have what we want, like the rays being emitting where the planet is not, right? I could come to the volume rays properties and increase the mask blur just to have the rays bleeding a little bit more over the planet. And yeah, you can go quite high, I think. Well, one more time, you decide about that. Don't forget that you can always go higher than the maximum of the slider in Nuke. So if the maximum mask blur of 100 is not enough for you, you can keep going and go a little bit higher. Okay, that's great. Now I'd like to adjust a little bit the visibility of my rays, and I'd like to do that according to the asteroids. And we are going to do that in the next clip. See you there. Alright, in this video, we are going to modify the visibility of the rocks according to the depth. So for now, those rays are casting all over the screen and on the top of everything, right? So we don't really get that feeling of rays interacting with those asteroids. And of course, it's a fake volume rays, it's a 2D effect, so don't expect to create something super realistic, but we can get something a little bit better. So, for example, we could simply create a merge node with the M key and set the operation to stencil, and basically plug it here and use our asteroids to mask a little bit some of the rays, just a little bit. That already will help a bit, right? But I think we can do better because we get a depth pass. So we could use a custom mask with the depth pass to mask more of the rays when we are closer to the camera than when we are back there, okay? So basically, I could use this mask, a little bit modified. So I will start from that mask. I will create a new grade node that I will connect after this grade here. I will come down here and hook up your viewer to your new grade node. And basically what I want is that those first rock are totally visible. There is no rays on the top of them, okay? So those guys should be totally white. And then we will fade off to black. So we have to imagine the invert images here. But for now, let's just make sure that everything is white right there. So we'll come here and adjust a little bit my white point, like that. I still want to keep like a subtle gradient here, maybe well, like that. And maybe I want to adjust this guy a little bit, I don't know. Okay, like that. I think it's great. All right, as well, let's make sure that we are clamping the whites as we did on the previous chapter to make sure we don't have an alpha above 1 when it's white. And I want to make sure as well I'm affecting all the channels and not only the RGB, but as well the RGBA. Okay? Now, as we said, we need to invert that mask. So I will type invert here and invert the mask. And now I will be able to use that to mask some of my arrays. Okay? So we'll plug my viewer to the end of the comp here. And now let's plug that guy here. And now it's a little bit better, right? Look at the difference. Here we're just affecting the stencil node is affecting and reducing the opacity of the rays all over the rocks. And here we can see that we are doing the same thing here, but not where it starts there. So I think it looks better. Maybe my stencil could come and be a little bit more strong now. I don't know, like that. And now that the elements are starting to fall into place, maybe we can start to readjust a little bit everything. For example, my color correct here, I feel it's a little bit too strong. So I will come to the ranges here and the mix to just remove a little bit of the color correction that I'm applying on the top of my volume rays here. Maybe my volume rays position could be slightly different, like that, maybe a little bit more at the bottom here. I don't know. You choose. Yeah, I like it a little bit more like that. Okay, now we start to have the look of the shot, but this volume rays right now is not moving, but our camera is moving, right? So we will need to introduce animation in that effect. And let's have a look to that thing in the next video. Alright, so now I'd like to introduce a little bit of movement in my volume rays in order to follow the camera movement. But for that, I will need to see how it actually moves right now a little bit. So I could just cache my shots in the viewer, but that will be very long and I'm not too sure that I will have enough memory on my computer to do it because the comps start to be a little bit heavy with the volume rays, with the defocus and everything. So sometimes it's better to just output a test comp. And this is what I'm going to do here, to output an image sequence that I could cache easily just to see what is going on in my shots. So I will hit the W key to create a write node that I will plug at the end of my comp, and I will navigate to where I want to save that guy. So I will save it to the material folder and I will create an output folder and another folder that I will call test comp. I will hit OK, and I will name my file the same way, test comp. And then I will render this time an image sequence. So for that, I will need to do a dot and pound, 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 pound. And this is for the frame number. This is how you do it in Nuke when you want to render out an image sequence. You need to specify the placeholder for the frame number. And this is how you do it by using the pound symbol. And you are going to use 1 pound per digits. So here we have 4 digits because we are at the frame 1001 till 1100. So this is 4 digits. So I will write down 4 pounds. And then I will specify the file extension. So in my case, EXR. So one more time, it's file name dot pound signs dot extension. And I will click on save. And now I will simply hit the render button from the right frame range from 1001 to 1100. I will hit OK, and I will pause the video and come back when it's done. See you there. Alright, the render is done. So a little trick to go directly to look for the file you rendered. You can select the right node and hit the R key to create a read node, and if you selected the right node before, it will jump directly to the folder where you rendered that node here. So I could select that guy and click on open, and that will create the read node. So I will hook up my viewer to it, and now I can easily cache that read node. So I decided here to render an EXR sequence, but for a test comp like that, you can decide to render whatever you want, a JPEG sequence, for example, or even a movie file. We could have as well render a smaller resolution to go faster, but I tend to render my pre-comp, my test comp, at the maximum resolution with a good file format to be able to see details and to be able to judge properly my work. Alright, so now that I have cached my shot, I'm able to know a little bit better what I should do with those rays. So first of all, I will need to animate the position of emission of those rays according to the position of the sun, and that will help a lot sealing the effect. As well as I think that at the beginning of the shot, I should not see the rays, and the rays should appear as the shot goes on and as the sun is revealing behind the planet. So let's move on to the next clip and start animating the position of the rays according to the position of the sun. See you there. Okay, in this video, we are going to use a Reconcile 3D node to animate the position of our volume rays. If you'd like to follow along, but you didn't follow along the previous videos, you can open the file v28.nk in the Nukes directory. Now, I know that I need to animate the volumetric center, which is that volumetric position here. And so I could just come here and create a keyframe on my last frame, and then come to the first frame and try to guess the position of the sun, and then hope for the interpolation to work well and eventually adjust the position 1 or 2 keyframes. But this method is not very accurate, and if the camera movement was more complicated, that would be a nightmare. We are going to use here another technique to find that volumetric center. And we are going to use the actual 3D position of the sun that we have here on our matte painting. For that, we are going to use a node that we call Reconcile 3D. So we'll create that node. And that node will help us using the position of the camera here, that I will need to plug to my camera, to my shot cam. We'll need as well to use the size of the 2D image output. So to find the size of the 2D image output, I just need to create a reformat node, and that reformat node will give me the file format Remember, we set up that thing at the beginning of this course. So we'll plug that reformat node to the image. And we will need as well an axis. And that axis will give us the 3D position of the sun. So we need to create that axis. So we'll hit the tab key and create an axis here. And I will need to match that axis position to the actual position of my sun right here. So for doing that, we have a very simple technique. So I'd like to just clean my properties bin to have nothing open in it. And I will just double click on my sphere because that's the only elements that I want to be open right now. And I will come to that menu, drop down menu here, and select vertex selection. If I click anywhere in my viewer now, I will display the vertices of the sphere. And the cool thing is that I can come and select a vertex, for example, that guy here. And now open my axis node and come in that little menu here and click on match selection position. And as you can see now, my axis is positioned on that vertex. So in order to match the position of the sun, well, we will simply need to have a vertex. Where is my sun? So right now we have that vertex, which is close to the sun, but which is not where the sun is. Because it's a camera projection, we could rotate that sphere to have that vertex being in the center of the sun. So let's do that real quick. So we'll just come here to the rotation and start to adjust a little bit. So I need to change the Y here. Okay, so that's more or less in the center, maybe a little bit more high. There you go. Okay, it's more or less in the center of the sun. That will do the job. So we'll select that vertex here and come back to my axis here and click on that button and match selection position. And now we have the axis at the center of the sun. Perfect. I will just need to connect that axis to the Reconcile 3D. Double click on the node and now create keyframe. So we'll make sure that my frame range is set to global to get the shot frame range, and I will click on OK. And there we go. Now if I look at the output of my Reconcile 3D, hit tab to go to the 2D position. Now we do have the 2D position animated, as you can see here. So this is great. This is basically the position of my sun. So I should be able to use that position in my rays here. So we'll open the volume rays and I will come here to the X, Y output of the Reconcile 3D, do a click on the animation menu, go to copy, copy animation, and I will come to the volumetric center here and do a click here, past, and past absolute. And now I should have exactly the same value here, and I copied the animation. So now the volumetric center of my volume rays is animated the same way as the position of the sun. All right, let's have a look to the result then. I will hook up my viewer right here. And let's see. Okay, cool. Let's check the last frame. All right. And let's see, for example, a frame like here. Good. I can see that my rays are following the center of the sun. So this is great. We got our volumetric center animated. But okay, let's say, yeah, but remember the position of my actual volumes were a little bit more like here on the edge before I modify the position. So what if I like to offset that position, but I'd like to keep the animation that calculated with the Reconcile 3D? Well, I could do that by going to the curve editor. So I'll come to the curve editor, and remember, if you don't have the curve editor here, you can click on that little guy here and go to Windows and then here, curve editor. Okay, and now let's actually close everything, go to the node graph and open only the volume rays, just to have a clean curve editor. And now let's see, I want to offset the X position. Well, I will select the X curve and come here and make sure I'm selecting all the keyframes. And now by moving the entire curve, on the y-axis here, I will be able to offset the position of my volumetric center here while keeping the animation. So that's very important to make sure that you selected all the points. You can do a Control A as well to select all the points. And then you can drag and drop up and down that curve to offset the initial position of the animation. And then now you have this position, but you are keeping the animation. And then that way you can get the exact result you'd like. So perfect. I think this looks better now. Cool. Now, we need still to animate the rays that appears, because right now we animate the centers, but we will need to animate other parameters of the volume rays to make them appear. And we are going to do that in the next video. See you there. Alright, so between those two videos, I rerun the test comp here just to be able to have a look to my new animation with the rays being animated. And I think it looks way better. Now, I'd like to animate another thing here, and it's how the rays are going to appear, because right now they are here all over the shot, but I'd like to have them appearing around here. We could imagine that they will be fully here at 1063, but before they wouldn't be there. So let's plug the viewer here. And now let's go to the volume rays, and I'd like to find the parameters I'd like to animate to make those rays appearing. So first thing first, maybe I should animate the ray length, as when we tweak it, we can see that the rays become smaller. So maybe it will give the impression that those rays are just coming from the sun, which will be, I think, great. But like if I go to 0, it seems that 0 goes reverse. So maybe it's, 1. Okay, if I go to 1, I can still see a little bit of the effect if I just toggle on and off. So this is not the only parameters that I will need to use. So maybe I will need to as well tweak the alpha options here, just to reduce from where the rays are coming from. So yeah, for example, I could imagine reducing the edge size here. I'm not too sure. It seems that there is still something a little bit. Yeah, okay. Or maybe if not the edge size, maybe the edge blur could work. So we are going to work with a combination of several parameters. I will check that guy here to revert to the parameters before I started tweaking the volume rays here. And now I will start animating them. So I will come to the frame where I want the rays to be complete. And I think I said it was like 1063. And on that frame, I will create a keyframe for the ray length, set key, and for the edge blur as well, and for the edge size, which are the 3 parameters that I'm going to use. Now, I will need to decide where I want my animation to start. So let's have a look to the render of our test comp to be able to scroll easily and see easily the result. And we could imagine them starting appearing around here, like 1045. I think 1045 could work. You can change whatever you want, and we'll be able to offset that a little bit later if we're not happy. So, but for now, let's go to frame 1045. I will hook up my viewer again to my main comp tree, and I will now reduce the ray length to 1 up, and I will increase the edge blur a little bit. I think that's it, right? I don't need to tweak the edge size. Yeah, no, they totally disappeared. So it's perfect. So we don't need to animate the edge size. So we'll do a right click and click on no animation. That will remove the keys I put it earlier. And now just before keep going, I just want to make sure that I'm at the limit, right? I just want to be at the limit where it starts appearing. So when there is nothing, but if I were moving the slider a teeny bit more, it will start appearing. Okay, cool. Okay, so now let's render that little animation. I could cache the shot in Nuke, but I already have this right node set up, so it will be very easy for me to just open it and click on render and go for it. But maybe before rendering that guy, I will disable the Z defocus. I know that this node is very slow to render, so we just want to see quickly what the rays are looking like. So I'll disable that guy, and now I can come and render it. So I won't change the name of it. I will just simply override the file because I don't need to have like multiple test comp. So there we go. I'll pause the video and come back when it's done. My render is done and I will try to cache that guy. I don't know why, it seems very, very slow. Sometimes when the script gets a little bit slow like that, you want to come to cache up there and say clear all, and you are going to clear Nuke's cache. So maybe it will speed up things again. So let's have a look. And for some reason, it's still a little bit slow. So what I do sometimes just to preview a read node like that, I will do it in a fresh Nuke. So I will come to File, New Comp, and I will copy that node inside my new Nuke. All right. You need to make sure that you are viewing the right frame range. So I went to the properties with the S key to go to the properties of the project. All right, and now let's have a look. All right, now it cached properly, so it's great. Okay, so the animation is nice. I'm not too sure. Let's see when it plays real time. Okay, cool. So yeah, I think the animation is right, but the timing is not. I think that we should start having those rays appearing way earlier, like right at the beginning of the shot, when the camera starts moving. So I think that, I mean, it starts moving from the first frame, but it starts moving a little bit faster from frame like around here, frame 14, 15. So let's go and move the first key of animation a little bit earlier in the shot. So I'll go back to my other Nuke script and open the volume rays, and I will go to the dope sheet. So if you don't have the tab here, you will have to click here and go to Windows and dope sheet. And if you remember from the first course, the dope sheet will just allow us to move easily our keyframes in time. So the two parameters that we animated for those rays are that guy, the blur size, and the ray length. And so those are the two keyframes, even if there is 4 keys, but it is the two parameters that I need to move, okay? So I will simply take those guys and drag and drop them something like, I don't know, I think this is 14. Yeah, 14. Okay, let's try like that. So I won't re-render the shot one more time. I will try to cache it in Nuke. So there is something which is very useful. You can do, you can click on the timeline here and do I of your keyboard to set an input point, and you can click another time of the key of the timeline and hit the O key of your keyboard to set an output point. Or you could use that button and that button. That way, when I'm going to try to cache this effect, Nuke will only cache between those two in and out points. And this is very useful. Okay, so I'm going to cache the shot. I will speed up the video, of course, but let's see how it looks like. All right. Well, I think it was way better. We could even offset it a little bit more. Well, you know what? No, I will keep it like that for now. Okay, cool. So now we got our rays animated. There is some little things that I like to fix maybe here, because we kind of have like a very bright spot and it's a little disconnected from the sun. But before fixing it, I like to add all the elements with the lens flare and other camera imperfections, because maybe, we don't know, maybe when we added like everything, it won't be that visible. So let's continue first by adding other elements, and we'll do the latest adjustments just before the end. All right, so let's move on to the next video to add the lens flare. See you there. All right, in this video, we are going to add the last layer of matte painting we didn't add yet, and it's the lens flare. So I will follow the same step I did with other layers by pre-multiplying, transform, reformat. So I'll copy and paste that group of node here, and I will come up there to plug to the lens flare crop, the crop 9 here. Okay, so now what do I have here? Let's have a look. Okay, so I do have my lens flare, and I will merge it on the top of everything before my read. Well, this is a contest read node, so I will put it on the side, and I will just create another merge node here, and I will connect my lens flare to it. And of course, I will change the merge mode to plus. Okay, so the position is not correct here, but remember we set all the matte painting position at frame 1100. So yeah, this is better. Now, I will need to animate the position of my lens flare in order to follow the position of the sun, and for that I won't have to redo anything because I already did in a previous video that reconcile 3D thing. So what I'm going to do, well, let's open the Reconcile 3D to have it open in the properties, and I will create a transform node here, and I will do the same thing as I did with the position of the volume here, and I will simply come here to the XY output, click on the animation menu, and do copy animation, and come to my transform node and do a past absolute. And now I will have an animation for my lens flare that follow the sun. The problem is that now it's out of the screen, and it's because we need to offset that lens flare, and we will offset it with another transform node. So I'll create another transform node with the T key again, and I will simply take that guy, drag and drop it here, and I will minus the values here. And now I will get the lens flare at the right position. It's a lot of transform node, but it doesn't matter. It's better that way. So we have the transform node that makes sure that everything is positioned properly for the matte painting with the reformat, okay? Then we have the transform node for the animation, and we have the transform node for the offset of the animation. Now, if you'd like to modify again the position of your lens flare, I will recommend you to do it on another transform node again. And because we just don't want to touch those guys, and these guys, I don't want to touch it neither. So now I could use that guy here. So now I have a lot of transform node for that lens flare. But if we were to play the shot, and I will just try to catch a few frames or just scroll through, you can see that now my lens flare is following the sun. Okay, cool. Now let's animate the visibility of the lens flare as we did with other things. But I think that the lens flare should appear when it starts to be a bit brighter here. So around frame maybe 1054 is nice. Okay, so for doing that, I could animate the plus, the merge plus here, or I could use, and this is more what I'm using usually, I could use a multiply node. So I'll hit the tab key and look for multiply, the matte one, not the merge one. And I will plug that guy right here. And so basically, if I adjust that guy, I will adjust the visibility of the lens flare. So when we are at the right, so I will revert that guy to 0 first, and when we are at the right frame, 1054 here, I will do a right click on it and set a key. Oh, so I don't know why my viewer get disconnected. It went to the other viewer. I don't know why. Okay. And now I will go maybe 2 frames before, and I will set the value to 0. And it's a little bit like if the lens flare was popping out when it meets the camera, like that. And I think this is great. Okay, I will cache the shot real quick. I will pause the video and come back when it's done. I just cached a little part of the shot just to see how it looks like, and I think it's great. I think it's great. Maybe we could use another frame to let that lens flare appear. So let's just go to the dope sheet and just let drag the keyframe for the multiply of 1 frame here. And just that small change should help us to smooth out the animation. See, I think it's better. All right, cool. Now let's move on to the next video to add a vignette, grain, and chromatic aberration. See you there. Okay, in this video, I am going to add a vignette, a bit of chromatic aberration, and some grain to the shot. I am not going into details about those operations because those are things that we did together in the previous course. But I will go slow enough that you can follow my step, of course. So first thing first, let's do the chromatic aberration. So for that, I will create a copy node with the K key, and I will plug the B inputs at the end of my comp, and I will create a transform node with the T key, and I will use that transform node to shift a little bit my red channel. So inside of the copy parameters, I will select RGBA.red to RGBA.red, and I will just scale up a little bit my red channel. So hook up the viewer after the copy node, and let's see how it looks like. So here we do have chromatic aberration. All right, maybe it's a little bit too much. So we are going to reduce a little bit that guy, put 0, 0, 0, and 8. Okay, yeah. Okay, cool. And to get more like the color of the regular chromatic aberration, I will duplicate that copy node, pass it here, and I will do the same thing with the transform here, pass it here, after the merge plus here, and now I will shift the green channel. Green channel, okay. Now let's hook up the viewer, and yeah, this is more what I'm looking for now. Now if I toggle on and off, you can see the difference. This is something we won't have too much in the center because this is more like happening around the corner of the images. So while I'm zooming around, I see some kind of weird edges and stuff. This is something that we are going to fix before the final output, of course. All right, now let's add a vignette. So for that, I will create a roto node with the O key, and I will draw my roto around up, all around the shot. And I will blur that roto. I will create a blur node after the roto with the B key, and I will put a big size of blur, like 200, and I will invert that with the invert node, and then I will create a grain node that I will plug after my chromatic aberration, and I will use that grain node to gamma down a little bit the corner of my image. I don't want to do it too strong, so yeah, just a little bit. 0.88. Okay, cool. And last but not least, the grain. So I will hit the tab key and look for the grain node. There we go. And same thing as we did in the other course, I will start from a preset, and for example, this guy here, I don't know. This guy is pretty thin. I like when it's not too much, you know, and I will reduce it a lot because I just don't want to have too much grain, but just to have it to give a little bit of more life. Now, I think that we have all the elements of the shot. So before rendering the final output, there are a few things that we need to fix and to adjust. So let's move on to the next video to adjust some of the little issues of our image. See you there. In this video, I'd like to adjust a few details. And the first details I'd like to adjust is to fix that black line around the rocks here. And that black line comes from the mask that we are applying to the volume rays. The mask that we are generating from the depth. As you can see, it's a little bit harsh, right? It's like very, very strong. And I like to smooth that alpha out. So I could do that by using a node that we called edge blur. So we'll add an edge blur after the invert node here. And as you can see now, it's a little bit smoother. And let's see how it looks like when we get out of it and we merge it on the top. And yeah, that's already way better. But then I feel that there is still like a line of 1 pixel which is extra here, and that create a sort of dot black line. So to fix that, we could use a erode node. And if you look at the alpha here, and after the erode, so we need to check the alpha, there we go, we can see that we are shrinking a little bit the alpha, and that will help us to blend things properly in our case. So we'll connect that erode here right before my edge blur. And now if I check things out, I can see that, yeah, now it's way better. Now things are smoothed. We'll see in the next course about keying that we need to be careful while using those nodes, but in our case, it just helped to blend the light, so no problem. Now that I see the image being like that, I think I'd like to smooth a little bit my volume rays as well. So I will open the volume rays and maybe I will add a little bit of blur out of it, like not too much, something like, I'm just always trying a lot just to, but like I will just use something like, I don't know, 7, 6.5, 7 is nice. It smooths things out a little bit. Cool. Now what else? Well, I will close the properties and look at my image. I think that we will help selling the image a little bit more if the rim light of the Earth was a little bit brighter. So let's do that as well. So I will come to the rim light here and I will increase the intensity. Something quite intense. Let's see with all the layers as well. It's important to see with the final comp to see how it looks like. Yeah, it's better. I think that having more rim light helped to sell the very bright sun behind. Okay, now I think that we have a lot of orange here. Of course, the planet is orange, but as well our God rays and lights on the rock are pretty warm. So maybe it will be nice to adjust a little bit the warmness of the sun. So I will come to my matte painting here and make sure that I'm after the sun layer. So shuffle to sun. Okay, perfect. So here after the crop, I could create a grain node with the G key and come here to the gain and switch it a little bit toward orange, just to add a little bit of warmness to it. Okay, cool, great. Now, last thing, I'd like to reintroduce the defocus that I disabled. So let's enable it back. But now maybe let's adjust it a little bit. So I'll close all the other properties and just open the Z defocus properties. So first, I think there is still a little bit too much of defocus. So I could reduce the size here and the maximum size as well. I just really want to add a little bit of imperfection because not everything could be sharp on the picture. So this is why, but I really want to keep it very, very low. And actually maybe to sell my shot, the focal point is not the right one. Maybe it should be better if we're focusing on the planet here and having the front of the image a little bit defocused. And maybe as well I could actually increase my depth of field to have more element chop. Maybe go over 1. Yeah, and now I think it's better. I get a little bit of defocus in the foreground elements, but in the background things are more sharp, and I think that's better for the matte painting to keep it with more definition. Another thing as well, if you'd like, you could introduce an overall color correction. And by that, we could use a color correct node or a grain node at the end of our comb after your lens flare. It's a little bit up to you to introduce any sort of color correction that you'd like. But just one thing, be careful with that. I will actually not do it because we are animating a matte painting. well, the matte painting have been thought like that, and the art direction have been checked and approved before. So if you have to modify the color of the matte painting, maybe talk to your matte painter before. Of course, if you are the matte painter, well, do whatever you want. But if you're working with a team, before modifying a matte painting, make sure it's okay. So there we go. Okay, now there is other things that we need to fix, and those are the imperfections coming from the 3D. So for example, the aliasing that we see around the earth here. And we are going to do that in the next clip. See you there. In this video, we are going to see how to adjust the scanline renders to add anti-aliasing and motion blur. So to illustrate that, I prepared a little scene here with a simple sphere with a checkerboard texture crossing the screen. And for now, it looks very sharp and unnatural because we do not have motion blur. So let's go and add motion blur. So I will double click on my scanline render and I will come to the multi-sample tab here. If it's not open, it's right here. And here we do have this parameter called sample. And as soon as I will increase that sample, you can see that things become a little bit blurry, and it's because we applied motion blur to it. This motion blur works by duplicating the image and blending them together. So depending on the motion you have, you may have to adjust more or less the sample. For example, the sample of 2 is not enough for us here because we can clearly see that there is those 2 spheres duplicated. Now, as I increase it, I create more sample, and at some points it will become natural. So the sample is one thing, and then we have another thing for the motion blur, which is the shutter. And that will be the equivalent of the shutter of your camera. This is not a unit of time, but this represents how long the shutter should be open where the motion blur is affecting your object. So if you modify that guy, you could have your motion blur a little less. If you put it to 0, it should be no motion blur. Or you could have it a little more if you like more trail, motion blur trail. Of course, if you'd like more motion blur trail, you may have to readjust the sample here. All right, I will turn back the shutter to what it was. And a last thing here is it's important to find the right sample for the motion you're currently using. For example, if you have a lot of motion, you will have to add a lot of sample, but if you don't have too much motion, you can keep the sample low. And this is important because it's very, very power consuming. So you really want to try to find the right balance for your sample. Okay, so the other thing I'd like to show you here is how to fix this aliasing that appears on our objects here. Because it's a simple sphere, right? We shouldn't have all those aliasing issues and all. Well, that's something we can fix by coming to the main tab of the scanline render and come to the anti-aliasing here and simply select another mode. And you can set it to low and as well medium or high. Of course, one more time, it's important to select only the level you need because this will be as well time consuming for your machine and it will slow down everything. Okay, so now that we know about those two concepts and how to adjust them, let's go back to my comp and adjust my different scanline renders before the final render. So we'll come here first to that scanline render and I'd like to adjust the aliasing of the planet here, which is pretty strong. So I will come here to anti-aliasing and I will just select medium and I think that will be enough. The other one that will need anti-aliasing will be the front element here. So those guys here. That could be a little bit aliased. I think it's not too bad, but we could just open that guy and just set it up to low. And that will help smooth out things. All right, great. Now, the other scanline renders don't need anti-aliasing. And why? Well, the first one here, we don't need it because we don't have edges. Basically, it's just a texture and we don't see the edges of the texture, so we don't need anti-aliasing. And for the other one, neither, because those guys have edges. I mean, we think it has edges, but the reality is that we are projecting on the card. So those edges are the edges of the texture, not the edges of the object. So anti-aliasing wouldn't affect anything on that case. It wouldn't change anything. Those edges will remain the same. So now we will have to add a little bit of motion blur. And for all layers. So the thing is that the camera movement is very, very slow. So if we go at the middle of the shot is where the camera movement is the more prominent. So I will use the frame 1050 as a reference to create my motion blur. Usually when you want to set the sample for your motion blur, you always want to go to the frame where it moves the most. And I will start with the sky because there's a lot of details, so that will help us to see what's going on. I'm zooming a little bit on it just to be able to see. So, and I open the Skyline Render 2, which is the Skyline Render for the sky, and I will go to the multi-sample. I will start increase the sample. As you can see, it's not a lot, but we are blurring a teeny bit. Like this is without, and this is with. We are blurring a teeny bit the sky. So, as you can see, I increased the amount, things are changing a little bit. But I really don't need to go very high here. The movement is very slow and we almost don't have motion blur. I think I will stick with a sample of 5. And if you find a setup that works great for one object, quite often you can apply it to others. Except if the motion is different. If, for example, the planet here were moving like very fast, or I don't know, where like we had like a ship passing by, this one maybe would need to have a different sample setting. But for now, I will come to that guy as well and apply a sample of 5 as well. And I will do the same with my other Skyline render. So number 3, 5, that guy, 5, that guy, 5, and finally that front element as well, 5. All right, so be prepared that now previewing your images will be a little bit longer. But let's do it. We are going to hook up our viewer at the end of the comp, and we are going to wait a little bit. There we go. So it was not that long, but it was way longer than without, isn't it? Okay, so I think that now I'm ready to render my final output. There is something I like to fix as well. You can see that we have that gigantic bounding box and it comes from the lens flare here. So I will simply come over here and create a crop node and put my crop node at the end of my lens flare branch here. And now I can simply hit the W key to create a right node that I will plug at the very end of my comp. And I will go to File here, and I will go to my material folder in my output folder. And I created already like a folder for the output final, but you can create a new folder if you don't have it. And inside the output final, you could name your file the way you want. So I already have an output final that I already rendered to try. So I will call this one output final 2. And now you want to add a dot and then pound for the frames, and then .exr, your extension. And if you have any doubt about that, please refer to the previous video of this chapter called Render a Test Comp. Then I will hit save, and I'm all ready to render, so I will click on render, verify the frame range, and go from there. Okay, this render will take probably a little bit of time, so I will pause the video and I'll meet you in the next video to see how it looks like, and as well maybe to assign you some little homeworks. See you there. Alright, so my render is done, so let's have a look to the results now. And for that, I could read the images in Nuke, but you can use as well an image sequence reader, so a player that will allows you to play image sequences, and I think it's better that way. So I really like DJView, which is a free software. So if you don't have any player for yourself, just go online and download DJView. It's very, very powerful, very simple, and it's free. So you just want to come to download and you will have all the versions for every kind of platform. So yeah, go ahead and download DJV if you don't have anything. Now let's play the shot. And yeah, I think it looks pretty good. As always, on the shot there are areas of improvement. For example, I think that those volume rays could be a bit more smoother, a little bit less visible as well. Also, maybe we could apply a bit of edge blur to the planets to blend it a bit more with the rest. And maybe the same thing as well on the first layer of asteroids. Well, this is the first version, and now you can take it to the next level, wherever you want. Now, as homework, I think it's time for you to try to animate your own matte painting, or photos if you don't have matte painting. You can break those photos or matte painting down into layers and then project those different layers into cards and animate a camera. You'll see, you'll get quickly some very exciting results. Now, this is the end of that course, and I really hope that it helps you to understand the fundamentals on how to use the powerful 3D features of Nuke, the camera projection, the ZDepth, and how you could use them to animate your own images or push your compositing to the next level. If you have any questions, any concern, you can reach me at florian.girardot@gmail.com or you can connect with me on LinkedIn. Don't be shy. Also, I encourage you to leave a review or a comment for this course. This is important for me to get feedback to make sure I give you what you need. That said, it was a pleasure being with you for this space trip, and I really hope to see you soon for more advanced comping. See you guys!